Everyone, and welcome to the PEAS RAB meeting of 28 February pre-recorded videos. So for new members attending and for those that may not know me yet, I'm Chris King. I am the Air Force Program Manager for PEAS, and I am tasked with managing the remedial efforts from past Air Force activities at PEAS. With me today are fellow members of the Air Force team, your community RAB co-chair, Ms. Andrea Miko, our remedial investigation consultants from Wood, Mike Daly from the EPA, and Peter Sandin from the New Hampshire Department of Environmental Services. We are trying a new format for this February RAB meeting, making use of this pre-recorded video segment. I will start by giving a short update on the status of the PFAS remedial investigation efforts to date and present some exciting new guidance documents issued recently by the DoD. From there, I'll pass the mic over to Mr. Hank Andelzik and Ms. Amy Quinton from Wood to present the validated RI remedial investigation, groundwater results to date, and the backyard produce results conducted last year. As you can see, this will be our agenda come the 28th when we have our full RAB meeting. Okay, this video will be played at the beginning of the RAB meeting held on February 28th. Following the playing of this video, we will conduct some RAB administrative business, meet the new RAB members, and get an update from the City of Portsmouth before we have our regular RAB question and answer discussions with the community. At that time, the RAB is encouraged to ask any questions related to the content of these videos. Later in the meeting, we will allow members of the community to submit public comments before adjourning. The public comment process will be discussed at the start of the Q&A session on the 28th. All right, next slide, please. Go back to the previous one, my apologies. So just to give a quick update on the status of the remedial investigation, we will present to you today what is essentially the phase 1 results. Phase 1 started in May 2021 and ended this winter before Christmas. Our consultants from Wood led the fieldwork and collected over 2,600 individual samples and drilled 76 new wells around former PEAS. The groundwater and produce data from this phase 1 effort are the subject of this RAB meeting and will be presented here shortly. This has been a massive effort to date, and going forward, we are looking to a lot more of the same. So we want to thank all of the community members that have given property access for sample collection and have participated in this RAB so far. All right, next slide. All right. Some good news. The DoD recently issued a guidance document conveniently called Guidance on Using State Per and Perfluoroalkyl Substances in Drinking Water Standards in Circular Removal Actions. So what this essentially does is this allows the DoD to consider state, not only New Hampshire, but other states' ambient groundwater quality standards when addressing private wells. This was not the case before. We were focused mainly on the EPA Lifetime Health Advisory limits, and so now we're allowed, not necessarily forced, to address state levels. Okay. What this means is that certain wells at private residences can now be connected to city water or install, public or point of use treatment systems. We're hoping to get some guidance from the Air Force, which is under development as well. Obviously, from the DoD, it goes to the individual services. And once we receive some guidance from the Air Force, we can start contacting potentially impacted residents. What this really means is that the DoD is engaged and they are putting out these new guidance, and this is really a huge win not only for the local community around PEAS, but any other DoD impacted facilities. So great news. Going forward, this is the start of hopefully a lot of good news to come. All right, next slide, please. Okay, right now we're talking about the remedial investigation. Essentially, this isn't the start of all these efforts. This started many years ago when they started doing, the baseline characterization of the sites. But we're in the remedial investigation right now, where we're looking at characterizing the site conditions to determine the nature and extent of contamination from historical releases. And we're also, during this phase, evaluating potential and current future risks to human health and the environment based on exposures. When we're done with this, we move into the feasibility study, and that'll be starting around right after the report is done in June 2023. So in that effort and the feasibility study, we will look to ensure that the appropriate remedial alternatives are developed and evaluated, and so that information can be presented to decision makers to make the proper decision for the future of PEAS. And following some public comment period, there will be a record of decision where we talk about remediation going forward. Okay, so next slide, please. All right, so this is an iterative process, and from now, I will turn this over to Hank Andelzik, and he will present to you the groundwater results to date from this phase 1 effort. All right, thank you.
Thanks, Chris. I'm Hank Andolsik. I'm a project hydrogeologist with Wood. And before I get started, I'm sharing the various groundwater maps we've compiled. I just want to introduce some nomenclature that I'll be using in my presentation. For those, excuse me, for those who might be first-time attendees, I'll start with a general introduction of the geology that comprises the former base and peninsula. It's important to understand that although I'll be showing you maps that appear to be in 2 dimensions, they provide data that also includes a 3rd dimension. The geology across the peninsula plays a significant role in how groundwater contamination spreads laterally as well as vertically. To begin with, the slide on the left is a cross-section of a glacial deposit typical of what you might see across the peninsula in the unconsolidated sediment deposits, also referred to in this presentation as the overburden. The clay, silt, sand, gravel, and cobbles that have been deposited were done so by the advancing and receding glacier. The rate at which water can move through the overburden is somewhat dependent on the grain size of the deposit. In other words, water tends to move more easily in cobbly deposits than it does in silty deposits. The image on the right is bedrock and typical of what you might see beneath the overburden. You can see in the image a series of vertical and horizontal breaks in the rock. Those breaks, called fractures, are how water moves through the bedrock. The rate at which the water moves through the fractures is somewhat dependent on their aperture, which is the size of their opening, and their interconnectedness. Next slide, please. This slide is another example of the movement of groundwater through various layers that make up the geostratigraphy across the peninsula. The sponge is an example of how water moves through the overburden. The sponge has many interconnected pores of various sizes. When you soak a sponge, you know it holds a lot of water. Similarly, the overburden holds the volumetric bulk of the water in the aquifer because of its high porosity and interconnectedness. The solid block of wood in the middle is analogous to bedrock. If it isn't fractured, there isn't much water in it. However, if you break the block of wood, like on the far right image, water can occupy the fractures. But as you can see from these drawings, that for the same volume of material, the sponge, or in reality, the overburden, holds much more water than the corresponding volume of fractured bedrock. Next slide, please. Here's an example of a generalized cross-section of the peninsula. The overburden deposits consist of the upper sand, the marine clay silt, and the lower sand. As suggested by their names, these are deposits of unconsolidated sediment. Beneath the overburden is the bedrock. In the top 10 to 20 feet of bedrock is referred to as the fractured bedrock, which is denoted by the light gray below the lower sand. This top layer of bedrock is generally highly fractured, so much so that it behaves hydraulically much like the overlying sediment deposits. Beneath the fractured bedrock is a more competent, less fractured bedrock. We refer to this as either the deep bedrock or just bedrock. And for water to be present in the bedrock, there needs to be fractures. All of these layers contain groundwater as depicted by the blue lines. Water flows with relative ease through all the layers except the marine clay silt and unfractured bedrock. The marine clay silt is not continuous across the peninsula, and where it is absent, the upper sand and lower sand are joined, and that unit is generally referred to as the upper sand. Where the upper sand is eroded, like along the western side of the peninsula, where you have an escarpment, groundwater is exposed at the surface along the contact between the upper sand and the marine clay silt, also shown on the image, where the arrow is pointing to the springs. Where this occurs, there tends to be the formation of seeps or springs. Springs are simply groundwater seeps that are flowing. Peverly Brook, Knights Brook, Pickering Brook all originate from springs along the upper sand marine clay silt contact. Next slide, please. In these images, you can see what the actual soil looks like beneath the peninsula, from the shallowest on the left to the deepest on the right. The left image is that of the upper sand. A little deeper, the middle image shows you what the marine clay silt looks like. And deeper still, the image on the right shows the transition between the lower sand at the top of the image and the fractured bedrock at the bottom of the image. Next slide, please. Now that you've got a basic understanding of the geology, I'm going to move on to discussing the groundwater maps. First, I'll walk you through the symbology that appears on the box plot and dot plot maps I'm going to be showing you. Just to orient you, north is to the top on all the maps that I'll be showing. What you see here is a box plot map on the left. These box plot maps were produced as an alternative to what is known as ChemBox figures. A ChemBox figure shows the location of the sample, then as a small spreadsheet with the sample results next to the sample location. The problem with ChemBox figures for this project is that there are hundreds of samples that have been collected across a very large area. ChemBoxes would simply be unreadable, and box plots allow you to quickly see, based on color, the distribution of contaminants across a large area. When we get the RI report produced, there will be accompanying tables to complement these figures that will provide specific values for each sample collected. So on the left side of the slide is an example of the PFAS distribution in the lower sand aquifer. The L to the left of the boxes denote lower sand, and the key to the lithologic symbol is in the box on the right side of the slide. The 5 colored boxes in a row on the left side of the slide represent the 5 compounds shown at the top right side of the slide in that order. So the first box is always PFBS, and the last box is always PFNA. These compounds were selected because New Hampshire has an ambient groundwater quality standard, AGQS, for 4 of them: PFOS, PFOA, PFHXS, and PFNA. And PFBS has a risk screening level, an RSL, for groundwater. These guidance values are shown beneath the listed contaminant at the top of the right side of the slide. Their values are nanograms per liter, also referred to as parts per trillion, or PPT. The color coding of the boxes reflect the general concentration of the compound specific to that box. White means it is non-detect. Green means it is detected, but was below the corresponding guidance value. Orange indicates it is above the guidance value, and red indicates it is 10 times greater than the guidance value. Next slide, please. The other type of map that I'm going to be showing you is what we call the dot plot map. The color coding is similar to the box plot maps, as are the contaminants displayed. However, these maps are contaminant specific. This map shown to the right of the slide is the PFOS distribution in overburdened groundwater. They're difficult to see on this slide, but there are a series of dots along the west side of the peninsula that have blue halos, and I'll show you this later too. Those points represent springs or seeps that were sampled. So anything with a blue halo is a spring or a seep. I mentioned previously in the general geology introduction slide that we consider the fractured bedrock to be similar hydraulically to that of the upper and lower sand deposits. So on this map, we have combined the geologic layers into just 2 layers: the overburden, which includes the upper sand, lower sand, and fractured bedrock, and the bedrock, which is all the bedrock deeper than the fractured bedrock. Unlike the box plots, which show concentrations of the 5 target contaminants across a specific horizon, the dot plot maps show specific contaminants across hydraulically similar layers. Although not shown in this example, I'll also be showing you preliminary concentration contours of specific contaminants with respect to the guidance values, which are shown at the top right of the slide. All right, so at this point, I'm going to begin with sharing my screen and begin with the box plot maps. Okay, I think Amy needs to stop sharing. All right, can everybody see that?
Yep.
Yes.
Okay, thank you. Okay, I'm going to begin with the box plot map that will show you what the concentrations of the 5 compounds I mentioned earlier, PFBS, PFOS, PFOA, PFHXS, and PFNA, look like at each sampling location. The data presented on this map are inclusive of all groundwater samples, all validated groundwater samples collected thus far as part of the remedial investigation, including samples collected during the base-wide and Site 8 site inspections, the expanded site inspection, and the routine sampling collected as part of the Site 8 and AIMS performance monitoring plan. The black dashed line is the Pease Development Authority property boundary. And I'm going to begin with turning on the potentiometric surface, which is a contour surface of the underlying groundwater across the peninsula. The high point for groundwater on the peninsula is at Site 8, which is up here. The former fire training area, where much of the AFFF was used. The blue lines are called equal potential lines, and groundwater flows perpendicular to those lines. So I'm just going to draw on here to move some things here. Did I stop sharing?
Yes, you did.
Sorry, it's blocking my sorry about that. I'm trying to get access to part of my screen. Here we go. All right, so I'm going to draw some I got to find my okay, I lost my cursor. So if rain drops right here, it's going to flow perpendicular to these lines. So it's heading down in this way. This is where groundwater moves. So it's also going in this direction. So it's running groundwater. These flow lines, or groundwater flow lines, are running essentially perpendicular to these equipotential lines. And so you can see here is that the source area is up here at Site 8, and as a result of it being the high point of the peninsula, there's radial groundwater flow from that area, which caused widespread distribution of the contaminants. All right, I have to move this back over so I can grab my hand. All right. Next, I'm going to show you the distribution of the 5 compounds in the overburden, which consists of the upper sand, lower sand, and fractured bedrock. And I'm gonna zoom out a little bit to make sure that we have the full domain of samples collected. And we have the one down there. And you can see it's a bit messy. As I zoom in, there you get separation between the boxes. So during the Q&A portion of this presentation, if you have specific questions about that, I can zoom into certain areas, and we can resolve the sample locations much better. But you can see the L and the F that indicates lower sand, fractured bedrock, and so on. So I'm going to just turn this layer off. And so I have the upper sand, the lower sand, the fractured bedrock, and the seeps, which all comprise the overburden. So I'll turn off these layers, and I'm going to turn on the bedrock, the deep bedrock. And this is what the deep bedrock looks like. And what you can see here is that the first box, which represents PFBS, as I mentioned earlier, is mostly white or green across this area. And the last box, which is PFNA, is mostly white, indicating non-detect. Most of the exceedances, the AGQS exceedances, are associated with PFOS, PFOA, and PFHXS. Now I'll show you what the map looks like with all the layers turned on. And this gets really busy. I know it's difficult to comprehend what's going on at the scale, but again, during the Q&A, I'll be able to move around, and I'll just give you an example. I'll just zoom in quickly here, so you can see how the separation occurs as you get closer to this data. So we can talk about it in more detail during the Q&A. So now I'm going to move on to the dot plot map. Here again, you see the PEA boundary, as well as the locations of the Haven, Harrison, Smith, Portsmouth, and Collins wells. I can turn on the groundwater contour map, but I'm going to leave it off for now because this map will get very busy very quickly. On this map, as mentioned previously, the upper sand, seeps, lower sand, and fractured bedrock are all lumped together and called the overburden. I'll begin with the distribution of PFOS in the overburden. There we go. As I mentioned previously, the circles along the west side of the flight line with blue halos around them are seeps and or springs. So this, I'll see if I can zoom in, but I think it's gonna make the dot smaller, but we'll see. Or you can see there's some here and there. So I'm going to zoom back out, and I'm going to zoom out so we can see the full scale of the samples collected. And make sure there's nothing to the south. Nope, just that one right there. So that's pretty much the full domain. Back it out one more time. Okay, so that's the full domain. Now I'll toggle through the contaminant specific dot plots. Next will be PFOA in overburden. So I'll turn this off, turn off PFOS, and turn on PFOA. And I'm going to toggle back and show you there's not a whole lot of difference. So that's PFOA. And that's PFOS right there. So not a whole lot of difference between the distributions. So back to PFOA in overburden. Now I'm going to look at, I'll show you PFHXS. And this is PFHXS. PFBS, there'll be a big change here. And lastly, PFNA. So I'm going to turn off the overburden layer for a bit and move on to the bedrock layer. So I'm going to turn off the PFNA, turn off that layer, and begin showing you what the bedrock looks like. And I'm going to start with PFOS in the bedrock. And PFOA, PFHXS, PFBS, and PFNA. So I'm going to turn the bedrock layers and I'm going to turn all the layers on just so you can see. And this is essentially, when I do this, it'll be essentially similar, very similar to what the box plots showed. Oops, no, not that one. I think I have everything on. Okay, so now I'm going to turn off the bedrock layer. And I'm going to turn off, I'm going to leave the PFOS layer on. What I'm going to do now is I'm going to show you concentration contours for PFOS detected in the overburden. So similar to the dot plots, the red lines mean that the samples within the polygon. So I'm going to zoom in a bit here. So the red lines means that samples within the polygons are 10 times the AGQS for PFOS. Samples within the orange polygons are above the AGQS, and samples within the green polygons are below the AGQS. So basically those are kind of trace levels. Anything outside the orange and inside the green is trace, and beyond the green is non-detect. So I'm going to turn off this green contour line just to keep it, just for housekeeping. It's a little busy. And I'm going to turn on groundwater contours. I'll turn on the groundwater contours. Well, actually, before I do that, I'm going to explain too about these what appear to be disconnected blobs. I want to point them out. They are not necessarily, so you have a bunch here and here. They are not necessarily the result of additional source areas. What is shown here is one way to interpret the data. As I previously mentioned, these contours are preliminary. At this time, we chose not to connect the outlying blobs. That's just for lack of a better name to call them, with the main core of the plume. However, you could connect them in some areas, and I'll just do that right now. I'm going to zoom in a little bit. And I don't have orange in my color palette here, but I have yellow. So we're going to have to pretend that my yellow is orange. All right, so I need to turn on the groundwater contours for this. So it's going to get busy again. And so if I was going to connect this, I'd connect it something like this, and that would connect onto that yellow or that orange main portion of the core of the plume, and that would come up, kind of come up like that. So you connect them like flow lines. So you try to draw them as perpendicular as you can to the equipotential lines. So that's how it would look if you connected them. So we chose not to connect them, these blobs of contamination, because our focus at the moment is the leading edge of contamination. So, here, 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 and so on, because groundwater is moving in this direction, in that direction, and in this direction. as that poses the greatest risk to the potential receptors. Furthermore, the heterogeneity exhibited in the hydrogeology and at times in the sampling data, and the episodic nature of the application of APFFF, which is the primary source of PFAS contamination here, further support this is a reasonable interpretation. I need to emphasize that these maps are dynamic and that they will be revised again as more data is collected. So I'm just going to clean up. I got to find my eraser underneath this. Here it is. And clean this up a bit. And grab my hand. All right. So now I'm going to turn off all the dots, but turn on the red and orange contours for the 5 PFAS compounds in the overburden, so you can see the interpreted distribution. So this is, well, let me back up again. This is I'll zoom out so we can see the full extent here. I actually missed something, didn't I? All right. Get the full extent. All right, and there is one point really far south, but I'm not gonna, maybe I will include it. And I'm gonna turn off the contours because it's really too busy with those on. Okay, so that's the PFAS distribution. And that is the contours. And I need to get the data turned off. So there. So that's PFAS contours. I'm going to do the same thing for PFOA. That's PFOA. And let's turn that off and let's look at PFHXS. That's PFHXS. And let's look at PFBS. And lastly, let's look at PFNA. All right, so now I'm going to turn on all of the overburden contours. Get a sense of, now you can see somebody's on green. I don't know. Right. We'll figure that out in a minute here. Right there. Still have somebody turned on here. That's it right there. All right, so no green on, just orange and red. All right, so now I'm going to turn off the overburden and I'm going to turn on the bedrock. And this is the contours here. Let's look at the contours and turn that off. Hang on a second, I got too many things turned on here. It's a very busy map. All right. So that's PFAS. This is PFOA. PFHXS. PFBS. Not a lot going on there. And PFNA. And again, I'll turn on all the layers now, all the contaminants, not layers, all the contaminants in the bedrock. And that gives you a sense of what's happening in the bedrock. So now I'm going to go back up and leave this on, and I'm going to turn on the overburden. And as you can see, how the distribution of the contaminants in the bedrock fall within that of the overburden. This is important because it suggests that the bedrock, at least at this scale, behaves similarly from a hydrogeologic standpoint to that of the overburden. This ends the presentation on the distribution of PFAS compounds in groundwater, and any questions you may have can be answered during the Q&A portion of this presentation. Thank you.
Thanks, Hank. I will reshare my screen and quickly introduce myself. My name is Amy Clinton, and I'm a human health risk assessor. And I'm going to be presenting today on the backyard produce sampling. So let's just get my slides back up. Go. Seeing the slides show where we left off earlier. And we'll advance it. So I'm going to start by talking about the migration pathways. So how contamination of PFAS from peas could potentially move into backyard produce and pasture grass. And then I will talk about the sampling program that we implemented to evaluate this exposure pathway. And then I will talk about the results that we have received. So we know that peas there's groundwater associated with peas that has PFAS in it that is moving offsite. This groundwater can be extracted by private wells, in some cases as drinking water, but in other cases as both drinking water or irrigation water, or in some cases only irrigation water. And from that water, it can be transferred to gardens. So we could see it potentially in soil of gardens, and there was the possibility that it could be taken up into fruits and vegetables. So the first part of the sampling program is attempting to evaluate whether or not that migration pathway exists and whether or not PFAS could potentially be coming into the human health food chain, essentially through the eating of vegetables that have been exposed to PFAS. And the second part of this sampling event, we're looking into the possibility of cattle being exposed and then people being exposed from potentially eating this beef cattle. So there's an extra step in this potential PFAS migration pathway. So we know again that peas has groundwater associated with it that has PFAS detected. In the farming scenario, it's not necessarily, although in some cases the cattle may also be drinking the water, but that's not what we're evaluating in this scenario. What we're evaluating is that this groundwater can become very shallow. And as Hank was previously talking about, there's areas where the groundwater comes to the surface is either springs or seeps. There's a lot of like wet land, wet areas around peas. And there's also something that we call hydric soil. So hydric soil is basically this poorly drained areas that tend to maybe flood out seasonally. They don't drain well. They may hold water for periods of the year, and where basically the groundwater is very, very shallow in these areas. So the potential is that PFAS can migrate from the shallow groundwater into this hydric soil, and there it could potentially be taken up by grass, eaten by cattle, which are then eaten by people. So these are the migration pathways that we attempted to evaluate. So looking at this figure on the left-hand side, we sent questionnaires out to this northern portion above the base and also to this western portion to try to identify properties where residents were essentially were extracting groundwater in private wells that were used for irrigation. And many of these residents are residents that we already know have private wells, are already in our drinking water system. In those cases, it was a questionnaire designed to identify what other uses they're using for that groundwater. Are they using it to water fruits and vegetables? In which case, if we already have data for it, we could sample, we could look at the data and say, well, if there's PFAS in it, then that's a potential home that we might like to sample fruits and vegetables at. If it's a home that they have irrigation water and we didn't have a recent sample, then we were requested to sample that water to see if PFAS was recently detected. So out of that questionnaire process, we identified about 16 homes that had PFAS recently detected in the groundwater that they were using to irrigate fruits and vegetables. So we asked for sampling permission to go to these homes and sample their fruits and vegetables. And out of those, we received permission for 11 properties that have fruits and vegetables. We sampled a total of 12 properties, and that includes 3 farms, one of which did not have fruits and vegetables. And that's how that selection process was made. Within that sampling program, we sampled a range of fruits and vegetables at each home. We aimed for around 3, but it depends. Backyard gardens tend to be very variable. You have very avid gardens that have many types of fruits and vegetables, and then you have more, let's say backyard gardeners who have perhaps a bit less success in their gardens and only had a smaller number. But we'll talk about what we actually found and what we were able to sample in a couple of slides. But this is just to give you an overview of how we made that selection process. And so looking at the farms, for a couple of the farms, we already had some information to suggest that PFAS was moving through the shallow groundwater and potentially into hydric soils on the property. And for another farm, we had some upgradient results that suggested that that was a possibility. So that's how we screened in that information. And again, it was very much in discussion with the property owners and finding out how they're using their property and what their willingness was to allow us to sample. And so as part of the sampling program for the backyard gardens, we not only collected fruits and vegetable samples, but we sampled again that irrigation water so that we could have a current timestamp of exactly what was detected at the time of the sampling. And we also sampled a representative soil sample from each of the gardens. With the farm sampling, we collected multiple pasture grass samples from each of the 3 farms. And with that, we collected at least one, and in some cases more than one, hydric soil sample, which was paired with a very shallow groundwater sample. And in some cases, we also sampled sediment and surface water if that was relevant in those particular farms. And so just again, those green areas that are shown here are where the properties ended up that we were able to sample. And given that, the extensive effort that we made to send these questionnaires out, and to contact and follow up with properties that we thought, might be impacted, we feel it's a fairly representative cross-section. And in fact, probably a large percentage of the homes that are actually potentially impacted were sampled in the sampling event. So here's just an overview, and we'll talk about a little bit more of the specifics. But so for the fruits and vegetables, we saw absolutely no detected PFAS in any of the fruit or vegetable samples. So as we said, the PFAS was detected in the water. So we know that the irrigation water did have PFAS in it. And in about half of the cases, we saw some soil detection. It was mostly PFOS only and at very low concentrations. So we were seeing definitely in the water, possibly, and in some cases in the soil, but none of that was transferring into consumable fruits and vegetables. So at this time, based on the sampling round, there's no concern at all for uptake of PFAS into fruits and vegetables by this pathway. And then looking at pasture grass, we saw no PFOS and PFOA and no PFBS. So essentially none of the chemicals that we have toxicity values for were taken up in the hydric soils. And there was very little uptake at all. We'll talk about a few more details about that. There were 2 PFAS chemicals. However, it was very low frequency of detection and very low levels. And none of that was in active pasture areas. So again, the outcome of this, based on this data, is that there's no concern for eating beef cattle that are grazing on these grasses. So here's a little more detail on what we were able to collect in this fruit and vegetable sampling event. Because there was no PFAS detected, there really aren't many results to discuss, but we can talk about what we found when we went out and we sampled. So we broke the vegetables and fruits into specific categories. These categories, essentially, it's either a root vegetable or it's an above ground vegetable. If it's an above ground vegetable, it's broken into categories based on whether or not it has a rind or skin that's removed or is eaten. These categories aren't very specific to PFAS. They're just convenient categories that are used in risk assessment. So we went with it, and if if we detected concentrations, we might rethink them. But in this case, these broad categories work okay, since we didn't have any detections in any case. But I will just talk through what we found. So on the top of this graph, we're showing the most frequently sampled type of vegetable, and that is also on the far left side of this little pictorial diagram. So these are exposed, what we call exposed vegetables, which just means you eat the skin. The skin is exposed to the air and you eat it. And that includes things like tomatoes, eggplants, peppers, summer squashes, cucumbers. I'm sure most gardeners have tried to or consistently grow many of these. Certainly tomatoes is one of the most commonly grown plants in New England, which falls into this category. And so, we found these on most properties and we sampled those most frequently. A subset of that is this dark green vegetable. So this is technically, it's an exposed vegetable, you eat the whole thing. But we pulled them out because the literature on PFAS uptake it's somewhat conflicting, but it suggests that uptake is likely to be more efficient for leaves of vegetables. So if there's anything that people are consuming, it's likely to be the leaf that may actually have the best chance, basically, for PFAS uptake. So we wanted to make sure that we collected as much dark green vegetable as we could in this sampling event. And as you can see, we got about 12 samples, which is roughly 1 per property. So if a resident was growing kale or lettuce, in some cases it was only things like sage and basil, which obviously you don't eat in as large a quantity, but they're still green plants. So we did collect those where we could. And then getting into the other categories where we didn't find nearly as many, there were a few fruits, not many root vegetables at all, only onions, and just the 1 butternut squash. Our sampling may have been a little bit early for the sorts of vegetables that would fall into that category. Butternuts, pumpkins, they don't tend to necessarily ripen until later, but we didn't note a lot of those being grown in the area. So, we feel that this cross-section is pretty representative of what is being grown locally. And as we said, there was none of the 25 PFAS chemicals that were sampled for were detected in any of the fruits and vegetables. So moving on to pasture grass, just going through, I'll start on the right side of this figure. So as I said, there were 3 farms that we visited and collected samples from. We collected 8 pasture grass samples from each farm. We collected them in and out of active pasture areas, and we also collected them in and out of hydric soil areas. So when we go through the results, we're going to see that we collected pasture grass samples associated with dry soils and with hydric soils. And we did this based on that information about potential uptake into leaves. We thought there was a good chance there may be uptake in this pasture grass. So we wanted to bound it. We wanted to figure out if it was detected in this hydric soil, did it stop being detected on the edge of the hydric soil, and was it not detected in the dry soil? So So these 8 pasture grass samples per farm, they were really spread out between areas based on what the soil was like. So was it in or out of these hydric areas? And then we also gave some consideration to what the farmers were currently using. So are they currently using this pasture land? They want to make sure that that's safe for their cattle. So we took some samples that were specifically targeted for active pasture areas, as well as potential future pasture areas, and just testing out this whole conceptual pathway. So we sampled, as I said, multiple media. So we looked at the pasture grass, we also looked at hydric soil, we looked at dry soil, there was groundwater. And when we collected this groundwater, what we did is we essentially, we dug a little sump. So we basically dug a foot deep hole and let it fill in with groundwater. So if you can imagine, that groundwater is really, really shallow. It's just in that first foot. And so that's how that shallow groundwater sample was collected, sediment and surface water. And we didn't actually collect a dry soil sample. So it was hydric soil, groundwater, sediment, surface water, and pasture grass that were part of this sampling event. And just to go through the little bits in the arrow, this is a little reminder of what the conceptual model here. And I also want to mention that this data, when we look at this, so we have PFAS potentially in grass, water, and soil. And cattle, they do eat the grass. Obviously, they drink water. They also do eat some soil. So the way that we'll capture all of that is that we do have a risk model which can translate all 3 of those media into a potential concentration in meat. So that's where this all is going, once we get to the risk assessment phase. So if we look through the results, let's talk about the top row first. So we show our location and samples. So this is a sample number of pasture grass samples that were collected in dry soil for that top row. There were no PFAS detected, with one exception in these 12 samples. So that 12 samples is half of our sampling event. There were a total of 24 samples across 3 farms. And out of that, for all 25 PFAS that we attempted to analyze for, we only found 1 detection. And unfortunately, as I said, we did not collect any co-located dry soil samples. So we don't have an immediate correlation for this sample. However, if you recall, last summer was a very wet summer. There was a lot of rain, and a lot of these areas, even though they're technically dry soil, were wet. They were wetter than they necessarily normally would be. And the shallow groundwater sample that was collected in the hydric soil sample that was on the same property did have PFBA in it. So that is one possibility. And so moving into the hydric soil, again, about half. So we had 11 samples that were collected of pasture grass that were collected on hydric soils. Again, no PFOS, no PFOA, no PFBS, none of the chemicals that we have toxicity data were detected, and no other PFAS were detected, with one exception. So in the hydric soils, we saw PFPEA detected in 2 samples out of these 11. And again, these are very low concentrations. I want to point out that they're J-flagged, which means that they're estimated values, that they're close to the limit of detection for the lab. So these are, considered low concentrations. And I also want to mention that we did have co-located soil samples for some of these. And what we found is that PFPEA was not detected in the soil, but it was detected in the shallow groundwater. Which brings me to my last line. So we took 1 sample in a spring. So this grass sample was sitting in sediment in perennial water. So there's water there all year long. And we collected this sample on the advice of the resident, who suggested that the cattle have in the past and could in the future visit this spring, both for fresh water and also to eat grass in this area. So we collected this sample to see what the concentrations would be. And what we found is that we were seeing uptake in the grass in that 1 sample. So we had 6 PFAS detected in this 1 sample. And when you look at the co-located data for one of our hydric soil samples and our sediment sample, we had exactly the same concentration of PFOS in the soil media, but we saw uptake into plants in the sediment, what we didn't see it in the hydric soil. So it suggests that that uptake could be coming more from the groundwater or from the water. So in the case of the spring, it's the surface water, which we know is impacted. So essentially what we're seeing is, we're possibly seeing that the water media is really driving any uptake. And I think that's also important to note that that's what essentially we're seeing in the literature. Again, some of the literature is very conflicting and it's hard to get a straight story. But what we find and what we've modeled in the past suggests that water is really the primary way that PFAS is taken up into plants. And that seems to be what these results are telling us. So just to recap what we've seen in the pasture grass, we did, as I said, we took into consideration what the active pasture areas were for these farmers and found no PFAS was detected in the pasture grass in those areas. The only place we did find PFOS and PFOA uptake, I should say, into grass was in that perennial spring sample, which is not currently being used for any purposes for cattle. And we did see that limited PFAS uptake in 3 of the pasture grass samples that were not in active pasture areas, but they were in the dry or the hydric soil locations. So, as with Hank's information, there's still analysis to be done, and we're figuring, we're figuring out how this will fit into the risk assessment process and where we go from here. And that's everything I wanted to cover today. So I think I will hand it back to Chris, who will go through what we're going to talk about next time.
Yes, thank you, Amy. So obviously from this presentation, everybody can see that this was a great deal of information, which is why we limited this to the groundwater results and also the backyard produce. So for the next RAB meeting, which will be in April, we will be talking about the remainder of the media. So soil, surface water, and sediment results, and along with the recent shellfish and freshwater fish and poultry egg results. So that should be a fun conversation as well. Next slide, please. There it goes. Okay, so obviously just a reminder of the remedial investigation timeline. It did start back in May of 2021, and it will be, phase 2 will be starting here shortly, and it's gonna go into the fall of 2022. Administratively, we expect our draft RI report scheduled to be complete March 2023. All right, well, that brings us to the end. You can go to the next slide, but I just wanna thank everybody who has participated in the making of this video. This has been an interesting process. Following this video, you at the same location where you've linked up to view this video, you can also find the tour of the Grafton drinking water plant operated by the city of Portsmouth. We encourage you to check that out. And otherwise, we look forward to seeing you on the 28th of February, where we can discuss this video and any other data further. This will be a virtual RABS, and we hope to see you there. All right, good night.
Welcome to the virtual tour of Pease Water Treatment Plant. Located at 97 Grafton Drive in Portsmouth is the Pease Water Treatment Plant. Constructed from 2019 to 2021, Pease Water Treatment Plant has a maximum capacity of approximately 1,200 gallons per minute and serves the entirety of Pease International Trade Port and a portion of the town of Newington. The source water that supplies Pease Water Treatment Plant is pumped from 3 groundwater wells: Harrison Well, Smith Well, and Haven Well. Pease Water Treatment Plant was designed to treat for per- and polyfluoroalkyl substances, also known as PFAS. PFAS are removed as water passes through 12 10-foot tall filters that are equipped with a specific type of media called resin. Prior to the resin filters, water passes through one of 4 cartridge filters. These cartridge filters capture any suspended solids that may be in the water. Water with a reduced amount of suspended solids flows freely through filter media, minimizing the chance of fouling or blockage in the resin filters. After the resin filters, water is then filtered a third time through one of 3 25-foot tall granular activated carbon or GAC filters. These GAC filters are the final polishing filters that would capture any PFAS substances in the event of any breakthrough from the resin filters. Granular activated carbon is also effective in filtering out other contaminants, including any taste and odor compounds that may be present. As water exits the GAC filters, it is injected with chlorine for disinfection, phosphate for corrosion control, and fluoride for dental health. After this chemical addition, the treatment process is complete and water enters the distribution system to be used by the public. Pease Water Treatment Plant is outfitted with inline analyzers and instruments that continually measure water quality parameters. Also inside the plant are 2 booster pumps that connect the Portsmouth water system to the Pease water system. These 2 booster pumps are each capable of pumping 600 gallons per minute from the Portsmouth water system into the Pease water system. Over the past 7 years, these 2 Portsmouth booster pumps played a significant role in supplying Pease Tradeport with enough water to meet daily demands. The Pease Water Treatment Plant is also furnished with a control room that houses benchtop laboratory equipment and 2 SCADA computers, which allow operators remote access to data and supervisory control. Thank you for coming along on this virtual tour. See you at Pease.
Thanks, everyone. Welcome. We're starting the live part of our Pease Restoration Advisory Board meeting. RAB members, we'd love it if you'd turn on your cameras. Hope everybody got a chance to eat a little food. Happy to see you all. And Cam, do you want to say a little bit about technology and then we'll jump into content?
Sure thing. Hi, everybody. I'm Cameron Hager with CBI, and just a quick little overview of the webinar format. Basically, if you are a panelist, you are going to be able to raise hand, chat, and unmute your microphone when needed. If you are an attendee and a member of the public, you will see that you have limited controls at the bottom of your screen. You're really going to have the raise hand function, at which point either Owen or I will unmute you, and that'll be during the Q&A portion of today's proceedings. But other than that, we will just let you know, you can message Owen and I directly if you have any questions about the technology as well. And yeah, other than that, pretty simple format, but if there's any issues, just let us know.
Thanks, Cameron. Welcome, really happy you're here. RAB members, it's fine if you had stepped away from your computers, if you had already seen that presentation, but if you are back, it would be great if you could turn on your screen so we can kind of be accountable to each other to be present. Thank you all. Tonight, we're trying a new model. You just experienced it. This is the model. So that RAB members had asked for the recordings of the presentations in advance so they could watch them a couple of times, pause, review, in addition to getting the presentation slides in advance. So we tried that, and at the end of the meeting, we'll send out a little evaluation and ask for your thoughts on how that worked. It also shortens the meeting conceivably, right? So you could watch the presentation first and then this be here just for this 2-hour block. We have 2 hours of really interactive session now. Going forward, we're going to introduce our new members, which is really nice. We'll do a little bit of committee business, and then we have about an hour for open conversation, for questions, comments, responses from the RAB to Chris, Hank, Amy, about the kind of major technical presentation that you just heard. And then we have 15 minutes for open discussion with RAB members. As you recall, the RAB have asked for just time where they can bring up anything that's on their minds and talk together. That's also where, if you have questions for Brian about the water treatment piece, we'll go. Although, Brian, I have you up for a couple of minutes right at the end of our sort of business. Great. And then we have time for public comment at 8:30. If you would like to make public comment, those of you who are watching this, you're very welcome. We'd ask you to email Linda Geisinger. Kim, if you have a second, can you put Linda's email into the chat by 8:10 so we can just manage for time? And then we'll do a meeting recap, next steps, give people a chance to share final thoughts on the RAB before we adjourn at 9. That is the plan. Questions about the agenda? I should say it was developed by and we always welcome all your ideas and topics. Okay, so that's the agenda. We are going to start by welcoming new members. So we have 20 seats on our Restoration Advisory Board. I believe 7 of them are appointed seats, and 13 of them are for community members. And those seats have 2-year terms, renewable. So people can keep serving, but we always check in with everybody after 2 years to say, do you want to keep serving, or is this a good time that you want to step down? We had people step down and we had people join in equal numbers. We are really happy to have 3 new community members. And I'm going to give you a chance in a minute to introduce yourselves. We also have a new appointed member because Colonel Pogorek has stepped down. So we will also introduce Matt Casey in that role. So I think, Chris, is there anything you want to say before I
none other than also included in this open discussion will be the regulators as well. So other than that, just please proceed.
Thank you. Great. So I'm going to invite new members. If you just, we'll do intros of everybody who can be seen here on the committee. I know you're sort of walking in. We're really happy to have you. And if you would, I'm going to each of you and just ask you to introduce yourself, in a few sentences, why you're here with us and what drew you, and maybe where you live or where you work as is relevant. So I would ask Samuel, would you go first?
Sure. Hi, my name is Sam Beam. I'm pretty new to the Newington area. We just moved, my wife and 2 daughters just moved here in November, and we're right alongside McIntyre Brook rather. So pretty close to the action. And I was doing some research on what's going on with the brook and the water and the whole situation, and came across previous meetings of the RAB meetings, and ended up sending an email, I think, and basically got myself volunteered. But I'm very pleased to be a part of it, and it's a lot of interest, very interesting and very important stuff going on. So I'm glad to be getting a good intro, and can't wait to dig in.
I'm glad to have you. Thank you. Russell, over to you.
Nice to meet all of you. I'm fairly new to Newington as well, having moved here about 2 years ago. I came out of my past company. For the past 20 years, we were doing EPA related work as well as conflict minerals work. And Mike Donahue, who I've known for many a year, suggested that this would be a wonderful place for me to keep current with what's going on with the Pease efforts on discovering and tracking and monitoring and remediating all the PFAS chemicals. So I'm looking forward to joining, helping out where I can.
Glad to have you. Thank you. William,
Hi, I'm Bill McQuillan. I serve as the City of Portsmouth's Assistant Fire Chief. I've lived here in Portsmouth since 1994, and I've been a firefighter here on the force since 1990. My involvement includes being on the Safe Water Advisory Group for the City of Portsmouth. And through that group, I was given the opportunity to come along here. In the past, I've done some advocacy and some work with the State Firefighters Union around the prohibition of AFFF foam, on the reporting of PFAS in our firefighting ensemble, and working on some laws to remove flame retardants from a lot of the furniture that we have. So that's a little bit of my background and my experience. I'm happy to be here, and good evening, everybody.
thank you. And Matt Casey, are you able to introduce yourself? We can come back to him. Great. It's nice to have all of you. Nice to be at our full capacity here. Oh, Matt is saying he's here. Matt, do you know how to, can you unmute? You want to introduce yourself? Oh, for a second it was working. There you go.
Can you see me and hear me?
We can hear you.
All right, great. Yeah, so I'm Matt Casey. I'm the environmental manager over at Pease Air National Guard Base, and I'm going to be replacing Colonel John Pagoric as the RAB rep for the Guard. I've been doing this job for 3 years so far, but I do have over 20 years experience in the environmental field. I grew up in the seacoast of New Hampshire. I have worked extensively in the Pacific region for the Air Force on a lot of similar former defense sites doing circular work. So I'm very familiar with the process we're going through here, and very interested in seeing how this plays out, and happy to be part of the RAB. So thank you.
Thank you. And Colonel Pagoric, I'm sorry not to be able to be here tonight, and say thanks to everyone. So he sends his regards, I know. We're going to do quick introductions of the rest of the committee so people know who's in front of them. And then we'll do a little bit of business and keep moving. So committee members, I'm going to call on you, and just if you'll just say your name and your affiliation, I think. Andrea and then Mike.
Hi, everybody. My name's Andrea Amico. I am the community co-chair of the RAB. I'm a Portsmouth resident and a co-founder of a community action group called Testing for Peace.
Thank you. And I realize I should say Mike Daly next, and then Michael Donahue.
Fair enough. Yeah, Mike Daly, US EPA Region 1. I work out of the Boston office. I've been a project manager overseeing the Superfund cleanup of the base for quite a long time. Still here, so
Thank you.
hope everyone's doing well tonight.
Mike Donahue, and I don't know how we get you sideways.
I've been working on it. I'm not doing too well, but I'm going. Maybe it's because I came down to Florida and I'm not in Newington, but I've gone sideways. But I'm glad to be at the meeting and see the new folks that have joined us, and I really am encouraged by the format. It's great. Thanks.
Brian and then Joan.
Thank you, Ona. Brian Getz, Deputy Director of Public Works, one of the older faces here, been involved with the PFAS project, so to speak, since we were notified that the contaminant was in the Haven well in May of 2014. Also not on screen, but support role, Al Pratt, our water resources manager's on, and Tim Green. A big shout out to Tim Green. Tim is our manager of the Pease water treatment facility, and Tim was the producer, director, and videographer of that great little video, giving you a tour of the facility. So good job, Tim. Maybe we'll give him an appearance here at an upcoming RAB meeting here. So, or maybe eventually, post-COVID, we might have an opportunity to take everybody on a tour of the place.
Thank you. That would be so great. Joan and then Chris.
Okay, hi, I'm Joan Hamblett. I am a resident of Portsmouth and I'm also a state representative. And I'm relatively new on the RAB. This is still my first term, I guess you'd say. And I guess my claim to fame is that I worked at Pease for a while and drank the bad water. So waiting to see what's going to happen to me. But I'm involved in the Pease testing as well. So thank you.
Chris and then Mark.
Chris, me? Okay. So I'm Chris King. I'm the Air Force Program Manager for Pease. Fairly new to the program still. I've been with the Air Force here and associated with this program for about 7 months now. So I'm looking forward to being with you guys for the long haul. So get used to seeing my mug around, I suppose. Thank you.
Thank you. Mark and then Kim. Mark, you're muted. Should be at the bottom left, maybe. There's a little microphone button.
How about that?
Yeah, there you are.
Top right. I had to switch from my computer to my iPad because I didn't have a camera on the computer. Anyways, I'm a 45-year resident of Portsmouth, mostly retired aquatic ecologist, and this is my third term on the RAB.
Thank you. Kim and then Peter.
I'm Kim McNamara. I'm the health officer for the city of Portsmouth, and I think I've been learning about PFAS since 2014. Does that sound right, Brian? And been with the city for 17 years.
Thank you. Peter and then Hank.
Hi folks, Peter Sandin. I'm the project manager for the Department of Environmental Services for Pease. Been involved since I started with DES, involved with Pease since I started with DES in 2014. And prior to that, I was in private consulting, also stationed on base and drinking the water. So we're all in this together.
Thank you. Hank and then Amy, since you are here, it's good.
Hi, I'm Hank Andolsek. I'm with Wood. I'm the project hydrogeologist, and I've been working on this project since 2014.
Great. Amy?
Hello, I'm Amy Quinton. I'm the risk assessor with Wood, and I've been on this project since I think 2017.
Thank you. Maria?
Hi, I'm Maria Stoll with the Pease Development Authority. I manage the engineering department there, and I've been there for 28 years.
Thank you all. I think we got everybody who's on our screen. Mike Donahue, I'm happy you're forward. You're upright. Good news. All right, let's go to, we're gonna do a really quick poll. I think Cameron's gonna launch that. For everyone, I think it's going to go to everybody who's here tonight to just ask, we just want to understand when people watch that presentation as we're trying to learn as we go. So if you would just choose when you watch the recorded presentations in advance, just now, neither, or both, that will be helpful for us.
Oh, now for me, it's saying hosts and panelists cannot vote.
Oh, so we're only getting the attendees. That didn't work. Okay, we'll have you do it in the eval. Thank you.
It let me vote.
It let you vote?
Yeah, it also
Yeah, I
let me
got the
vote
vote too.
50-50.
Oh my gosh.
I voted as well.
Not statistically accurate. All right, thanks everybody. We tried.
I voted twice.
Perfect. 5 times mark. All right. We have a meeting summary to approve from September. I'm sorry, my apologies. We forgot to send it once we had sent it out to all the RAB members. You saw it like 2 months ago. We got one person who gave us some feedback. Thank you. And we incorporated that. I sent it out like 3 minutes before the 6 p.m. start. So it's fine if you want a week to look at it before we approve it, just let me know now. Or if people don't need that time and trust, we made just a couple minor tweaks, which I mentioned. Mike, go ahead.
I was the one that gave you the feedback, and I reviewed it quickly, and those minor tweaks are great. They're perfect, and I'd like to see it approved and just keep this going quickly.
Thank you. Any different opinions, or we will consider it approved? All right, thank you. And then Brian, I think we wanted to give you the floor for just a couple minutes. I don't actually know the details there, but over to you.
Well, Chris had just said provide a quick update. Everybody got a nice tour there. Again, thanks to Tim Green. And if you've driven by the facility right there on Grafton Drive, it's been up and operational since April of last year. As far as the resins go, prior to that, the Harrison and Smith wells were being treated since September of 2016 with granular activated carbon. So now we have the dual system of the resin filters in front of the water going through the resin first, and then to the carbon, and then to the system. And we monitor it. Initially, it was weekly, and then after a good sampling and seeing the performance, which was non-detect, we have shifted to monthly sampling, which we continue. And to date, everything is still non-detect through the. And we've got the Haven well was reactivated, which I did present at the November meeting. It was reactivated in August, so it has been in the system and operational since that period of time. We generally run the system, all 3 wells, for the most part together. So it's a blend of those 3 wells, but they all go through the treatment together, and everything, again, as we monitor the system to date, is non-detect through the filters. So that's very good news there. And we're continuing to work with our consultants who've been with us through this project, and also the Air Force and their consultants on assessing at what point we would be getting to the point of change out. But that will evolve here in time as we continue to gather performance data from those filters. And again, all pointing in a pretty good direction with that. So with that, that's pretty much what I wanted to say. And we'll continue to report. We've reported this and some of the data on the Safe Water Advisory Group. They're meeting last week, and we're preparing our annual water quality reports, which at the next meeting, I'll be able to get out to everybody to see, in summary, all the data there for the year.
Thank you. So I think we should let any questions for Brian come up a little bit later, if that's okay. Thank you, Brian. Appreciate that. And just jump into general discussion. So now we had this presentation. We didn't, right? There were no interruptions. Hopefully some of you had a chance to watch it ahead and pause or go back if you needed to, but I'm going to open the floor to RAB members. For those who are new, or as a reminder, because it's been a little while since we've had a meeting, you can use the virtual hand raise function, or you can put a note in the chat that you want to comment, or you can just try to get our attention, and we will call on you and try to take things in kind of a logical flow. So inviting RAB members, responses, questions about all that water and produce content? What did you hear? What are you curious about? Andrea, why don't you start us off?
Sure. Thanks so much, Ona. I just want to say also thank you to the Air Force and Wood for preparing all of this ahead of time, and Brian, to Tim too. I thought it was super helpful to get the information ahead of time, especially this data is very technical. And I think I had told you I kind of glazed over watching the maps the first time. So being able to watch it a couple times just was helpful, and having it ahead of time just made it a lot easier. So thank you very much for the effort that went into putting that together for us. I really appreciate it. So Hank, I just have a few questions for you. So definitely having the color-coded bullet, dots were very helpful from like a visual perspective, but I'm really curious if you can elaborate a bit more on the actual levels. So I know the red dots were 10 times over the standard, but I'm just curious if you can, 10 times over could be, 100 parts per trillion, it could be 100,000 parts per trillion. So are you able to just elaborate a bit more on the levels of PFAS, or like give us a general range of like maybe the highest detected PFAS that you found? And then also, I know that you reported on, 5 PFAS, but it's my understanding that you tested for 25 PFAS. So if you could also let us know how many PFAS were detected. Was it just these 5? Were there additional PFAS detected? Because I think, one of the things we've said in this RAB from the very beginning is that our community cares about all the PFAS in the water, like not just 2, not just 4 or 5, like everything. And we know that AFFF was a mixture of PFAS compounds. So it's important to us, even if there's not standards or regulations or health advisories, it's important that our community know exactly what you're testing for, what you're finding, and at what levels, kind of regardless of those regulations. Thank you.
Let's go to Hank to respond, and then Kim, you'll be up next.
Okay. Thanks, Andrea. Yeah, I'll share with you what I can. I'm going to stop my video, but I'll start sharing my screen here in a moment. Can anybody see that yet? Oh, hang on. Try that. Here. How's that?
Yep. Good.
Okay. So I can, the long answer, Andrea, is that based on this is just an example, what I showed earlier in the video presentation. This is the PFAS in overburden distribution, and just from these dots, I can't tell you exactly what each one of these. Well, I can. Well, what I can do is I'm going to try to move my. What you can't see is on the top of my screen. There's a banner that I need to move, and if I accidentally stop sharing, there we go. So I can go like that, and it gives me a value of 0.047. But that doesn't really help you out. I have a table that I prepared that I will share with you, and this is a summary of there's 25 compounds that we analyzed for. And this is the highest concentrations that were detected of those 25 compounds. The yellow highlighted compounds are the ones with associated AGQS values, and also we have PFBS in here because there's a risk screening level. So there's the 4 AGQS values plus PFBS, and these are in parts per billion. So in parts per trillion, add 3 more zeros. And this is the highest concentrations detected. And here's all the other compounds that you were asking about, the highest concentrations detected. And I can get this to you. I can send you this summary. And these are the locations. So most of the locations are at Site 8, and most are either in the fire training area, are in the trough. So essentially in the extraction well network in the collection system. There's one, this is the site, this is Ames down here. This is the Ames extraction cutoff well, that's PFNA. And then we've got some other ones associated with them, landfills. So hopefully that answers your question.
Yes, it does. Thank you. And it would be helpful to be able to get a copy of that document, because I mean, just
Absolutely.
looking at it quickly, it looks like there's some places with some really high levels of PFAS. And also it looks like there's a lot more than just 5 detected, you know, and I think, again, that's what's important for us to know, you know, because again, we're not just exposed to 5, or our community hasn't been just exposed to 5. We've been exposed to many. So that's just helpful to know. Thank you.
Sure.
Great. Let's go to Kim and then Mark. Kim, you're on mute.
Now?
Perfect.
Thank you. We've been pretty overwhelmed dealing with COVID, so I'm feeling a little behind. So these questions are really just to catch up for the group because I missed 1 or 2 meetings. I really appreciated the pre-recorded presentations, and I really appreciated the detail they went into because it just helped reframe things. If I understood correctly, bedrock, you know, is fine if it's not broken, but when it becomes broken and cracked, it acts just like the overburden. And so how much of the condition of the bedrock out at Pease is going to play into the long-term cleanup goals? And are we thinking about things like if there's further construction of, you know, new airport features, or if there's just new construction on PDA property? Is that going to be figured into the remediation plans? That's my first question.
Thank you. Hank?
No, I guess I'll take that one. And if anybody else wants to jump in, please. I mean, there are developmental restrictions already on the PDA, particularly when it comes to breaking that ground and interfering with that water and harming wells in particular. So is what's going on at the PDA going to be factored in? Yes, of course. That is, and the overall extent of this contamination as well. But that's kind of the short answer. But yeah, for them there's a big process in place already should they intend to develop something new that cracks the surface, and especially around active monitoring wells.
So if there is going to be additional airport services due to additional potential airport development, there will be preconditions that these developers will be well aware of before they get any permits for that. Is that what I understand you to say, Chris?
Yes, but I would also like to defer to the PDA on that if anybody wants to jump in, but you do have your own internal processes for this as well. Anybody from the PDA want to jump in?
Yeah.
Hi. Yeah, I guess just to restate what Chris said, I mean, since the beginning of development of Pease, we've worked with the Air Force, and whenever we've been in contaminated areas, we go through an approval process where we present a plan to the Air Force and to the EPA and DES, and it is reviewed so that, you know, we're not moving water around, we're not moving plumes around, so that developers or workers know that they're in an area that there might possibly be contamination, so that this process is well established at this point.
Thank you. One point was made during the presentation that PFOS, PFOA, and PFHXS, you know, were at exceedances, but even if those exceedances are mostly related to those 3 compounds, does it matter when it comes to the remediation? Remind me, is remediation for every PFAS compound the same?
Again, this is Chris. These chemicals are very similar, I guess, in their structure and nature. So that, and you can see from the data that Brian gets supplied as well. They're starting to see non-detects basically for all PFAS related chemicals that they test for as well. So the treatments that are currently available to us seem to be treating all of the PFAS that we test for to some regard. There are some smaller chains that could break through eventually, and we're seeing some evidence of that at Site 8. But it's basically when it's an indicator that things get changed out, then we do. But hopefully new technologies, we're keeping an eye on them as we move further and further into the future with the science. Hopefully some new things will pop in there, and yes, and make sure they keep treating all of these ones that keep getting identified and the current ones that are regulated as such.
Thank you.
Mhm.
Thank you. Mark, you are up next.
Okay, thank you. I must say that I was absolutely stunned by the GIS use of the contour mapping, well mapping, and data in Hank's presentation. Absolutely loved it, which got my mind running a little bit with it. And humor me on this, Hank, because it's really a naive question, but could you take the volume of each contour, of each concentration level, of each of, say, the 5 PFAS chemicals that you showed us, and estimate, I'm looking for like a lump sum number, and estimate, say, how many pounds of each one is encompassed in, say, the top surface sediment layer or something like that. Because what I've been struggling with since the tour that we had of the remediation plant, the new one on the upper east side, northeast side of off of Arboretum Drive, is we have a number of how many gallons of water is being treated and dumped back into the ground. But I want to put that in perspective with what's in there. In other words, is it arbitrarily 50 gallons out of 500, or is it 50 gallons out of 50 million?
Yeah, I understand what the question is, and yes, we can certainly go through that exercise. I mean, there's limitations to it, but I suspect that we're going to end up doing that anyway as part of the RI report evaluation, and specifically the fate and transport modeling that's going on, because we're going to have a source term in that. But yes, I mean, it's a fairly, I mean, again, it's not exact at all, but it's a very straightforward calculation, at least for the overburden. Bedrock is a whole different thing because we don't know what the porosity is per se, so that becomes more difficult. But most of the transport is occurring in the overburden. So yes, we could come up with that, and I suspect our modeler, I'm not the modeler, our modeler will likely do that, and we can actually use GIS to do that function.
Yeah, I'm waiting for the movie.
Yeah.
Right. No, but because it's dynamic too. It's spreading, it's diluting.
Right.
From the source, for example, or sources. So yeah, snapshots in time put together. Yeah, and then link it back to just, you'll have enough information from the performance of the remediation plant to put the two together and see if you're making a difference or not.
Exactly.
Thank you. Let's go to Jean, and then Brian, then Kim.
Hello?
Yep.
Can everyone hear me? I have one question on the remediation. How many gallons since the start of this project has been gathered? Or I saw a tank there, and I remember seeing, I never asked how many gallons of PFAS was actually collected, but how much has actually been pulled out of the ground and how much has been totally pumped out of the ground?
I don't have that answer. That was actually brought up at the last RAB meeting when we had the breakout on Site 8, and the operators at both plants had those numbers at their fingertips. And I unfortunately I don't have those answers.
It was roughly about 500 million gallons of groundwater have been pumped from the two remediation systems, and on the order of, I don't know, 30 or 40 pounds so far of individual PFAS compounds.
So that's a total of how many gallons?
Of AFFF or?
Of all the PFAS compounds approximately.
Oh, I don't know what that translates to. I mean,
Yeah.
and that's not the point so much of the remediation. It's the hydraulic control and reinjection of the clean water. From a cleanup standpoint, there's still, you know, the vast majority is still in the ground. But really it's establishing that hydraulic control and flushing the clean water back in.
Another question is, are there any, if they have dewatering projects or any construction projects at Pease, are they required to do something with the water, test it and or treat it?
Yeah, so that's part of that process that Maria and Chris touched on earlier. Anytime there's going to be, basically when PDA is alerted through a development or any kind of investigation work that's going on, if a dig safe permit is generated, then they will look at where that work is being proposed. If it's in an area of the contamination, either the historic legacy contaminants, the fuels and the solvents and things, or in PFAS, then Air Force, DES, and EPA, we get together, we look at the work that's being proposed. If it's construction work with dewatering, then we alert PDA to alert the developer that they'll be encountering, either will or will not be encountering contaminated groundwater that should be properly managed, or if it was contaminated soil or whatever it might be for that particular area.
Mm-hmm. And one more question. This is for Brian.
I'll just say last but not least, for that, if there is construction dewatering, so the groundwater that's being removed has to be filtered, then that process would be managed by our DES Drinking Water and Groundwater Bureau through a temporary groundwater discharge permit process.
And has that occurred at all at
Oh, yeah.
Pease? It has.
All the time.
Okay. So they have to bring in a remediation trailer, or do they?
Yeah.
Okay. And the other question is for Brian is two. One is what's the final, where are they putting the final PFAS that's all spent? That I know that I heard incineration and all of that a couple of years or so ago. Is that still where the ultimate where the spent carbon goes and the resin?
Yes, the previous change outs of carbon have been incinerated. So the carbon vendor with the same, they actually show up with the fresh carbon, and they have a two bay trailer that actually the one bay takes the old carbon out of the filters, and then the new carbon's put in. We are working on a overall plan for the resins, but you know, that is a work in progress right at the moment. We don't imagine having currently, given the performance, it'll be some time before we have to change those out.
Okay, thank you.
So Tim Green did give me an update. We're at 170 million gallons to date through our system. So that's the volume there. I had two questions. The first one, I thank Kim for bringing up this point about activities at Pease. It reminded me that there's been discussion, many a meeting about the groundwater management zone, whether that's been updated. So now, given all this new data, whether there's going to be again, a new groundwater management zone map for the PFAS.
Yeah, I'll take that. So that is one of the many outcomes of the RI will be ways to find in the nature and extent, and part of that is the nature and extent in groundwater. So what is the full extent conservatively that it's impacted, and once we know that, we can establish the groundwater management zone.
Okay, great. So the other question was about the sediment sampling and whether there was correlation of when the sediment sampling was done, whether it was correlated to any of the groundwater sampling. Might be a Hank question or Amy.
I think you're gonna have to get more specific with your question, Brian. I don't quite.
Well, I mean, when you know, some of your data that you're gathering of essentially the above ground stuff or the plants and stuff, whether or not, you know, that's correlated with either water that's gone by in the streams or the water that's underground in the area. So I guess it's a Amy question.
Yep.
Amy, you want to take that?
I'm not sure. I'm not sure I have an answer for that.
So it sounds
Okay.
like
Well, I mean, Brian, I mean the streams leaving the former base or surface waters leaving the former base are contaminated. So so surface water is contaminated for the most part. The groundwater in areas are contaminated. The hydric soils, some of the, I don't recall, Amy, you might help me out here, but some of the seep samples that we took from the hydric soil zones are contaminated, but I don't think there's a link. She wasn't able to make a link between that and the plants. And the only link that appeared to occur was when the plant was in the water. It was growing in the water. And that came back, that plant came back elevated.
Thanks, Hank. We'll go to Kim and then Mark and then Sam.
Yeah, I think when it was Cam's introduction, he made a point to say that we can now use state standards for remediation instead of the federal ones or the ones we used to rely on. Is that the RAB's choice about what standards are used for cleanup at Pease?
Chris, I think that's probably to you. You're muted. Yeah. There.
Yeah, sorry about that. It's also basically it's a little more complicated than that, and I know I have some legal people in here that may want to jump in, but the state standards are really only considered when a federal standard is first violated. Of course, we know that has occurred on Pease, and so it's not really, you know, it's one triggers the other, and so at that point, some of the state standards move in, but then it's you know, of course, we established the EPA, you know, they set the cleanup level, the goals at the end, and along with New Hampshire and the Air Force at the record of decision time. So those standards and cleanup goals will be established, you know, a few, you know, some steps down the road. But short answer is because go ahead. Thank you, Sharon.
Yeah, this is Sharon, an attorney with the Air Force. As Chris was saying, that the decision on what standards are going to apply is decided when we get to the record of decision. We start looking at it in the RI phase, looking around to see what standards are out there, and we start talking to the regulators about it, but they aren't actually chosen to the ROD. So it is not a RAB decision on whether it will be federal or state standards. It comes down to looking at what the law requires us to look at, which is it a promulgated standard? If a state standard is more stringent than a federal standard, that would probably be the one that's chosen, for example, if it's relevant or applicable to the situation at hand. And I'm not trying to be opaque or use lawyer fees. They're very detailed analyses that we have to do when we get to that stage.
Yeah, this is Mike Dale. I just, again, and just confirm what Sharon was saying, you know, that is true. So, you know, part of the RI is what's important about the RI is not only collecting the data, but assessing it through the sort of formal risk assessment process. So once you've determined that you have a risk, and again, if we're looking at groundwater and looking at appropriate either risk-based or promulgated standards, once you've established there's an unacceptable risk, and that's defined either by cancer, non-carcinogenic risk thresholds, then you start to look at a variety of what's available in terms of either federal and or state criteria. So, so yeah, like Sharon said, it doesn't really come into play until you've gotten to that threshold. But with that said, we're all working on the premise, and all the data that's collected is just basically assessed against those more strict state standards as we go through the RI process. So I think that's what's most important, that we're essentially looking at those in addition to the other 25 or so that are being evaluated, but more importantly, or most importantly, those which have standards. So and making sure that the data quality objectives, that the quality of that data can actually meet those standards. So when you're basically comparing a data point, that it's at least as low as that particular standard that you have identified, preliminary identified as part of your sort of initial evaluation or screening of ARARs that are out there. So so that's just sort of it's a lot of circleese or circle jargon, but that's basically how the circle process works.
Well, I can only speak for myself, but if we get to the point where the lower standards are not chosen, I would like to have the opportunity to argue later down the road about that.
I think definitely the RAB will want to talk about that topic further on.
And my last question, I feel like one of those guilty students in school that forgot a lesson here, so I apologize, but what is being done to protect the Haven Well from all contamination now and in the future, since it still sits in the middle of the flight line?
Well, I can speak to that on what the Air Force is doing right now. There is an extraction system, and let me see if I can pull this up. Hang on a second. And I'm going to have to turn some features on here.
And while he's pulling that up, Chris is speaking again. A lot of any future contamination is probably, there are businesses around Pease Airport now, so it's going to be a lot of that management is going to be up to the airport and the businesses that operate and have chemical operations in that area as well. So at that point, any future contamination isn't only on the Air Force. That's in the past. The stuff that's ongoing now and in the future is around that well as other businesses. So they are going to have their own pollution control mechanisms in place. Hopefully hopefully we'll never see anything added in the future. That's the plan. So
Kim, I can just add that the airport and airport tenants are very aware of the Haven Well. We have spill plans, we have stormwater plans, environmental protection plans, and everyone who operates on the airfield is aware that the Haven Well is there and it needs to be protected. It's not the way you build it today, but it is what we have, what we've taken over, and we've been dealing with it that way, and we'll continue to be very protective of it.
And something else I'll add to remember is that we've got a very extensive long-term monitoring plan for the entire airfield. It's with the Haven Well and the other supply wells being the most important parts, but the monitoring well network up and down that we're looking at right now, the wells that were chosen for periodic sampling are selected. They're called Sentry wells. So we're looking at travel times from groundwater as the groundwater moves towards each of the supply wells, so that we're not surprised by a contaminant showing up in the supply well. We'll have years of advance notice if we see movement occurring towards anything, so that there's time to react. So that's how that plan was developed.
Okay, so can everybody see my screen?
Mhm.
Okay, so so what we have in place, besides all the monitoring well network that Peter was referring to, which we sample regularly, and also the treatment system that is on the Haven well that Brian, we had that tour, we went through that virtual tour, so that's treating point of use from the Haven well. But there's also a series of extraction wells that basically go right across here. And so this is capturing groundwater, and you can see the red here. And this is capturing groundwater, and you can see actually some of these contours are bending in. So the groundwater is coming in into this zone here. And these are capturing groundwater, and that's being treated in a similar treatment plant to what the city is operating, but we have it's the airfield mitigation system, Ames plant, and that's treating it, and then it's injecting the treated clean water. Basically, I don't know, it's somewhere in this area here. There's a series of injection wells so now we're flushing clean water down through in this direction. So this gets captured. All this gets captured and gets pumped out clean. We start a clean wave here. We also have a well right about here, which is called the intermitigation well, IMW, and that is pumping water and going back to the treatment plant. So that's helping basically create a kind of a clean water shadow on the down gradient side towards the Haven well. And there's also a series of clean water injection wells in this area here. And that's also flushing out clean and treated water. And that's heading down towards the Harrison and Smith wells further down. So that's what's happening right now.
And Hank, my final question. So whatever you're using for treatment and what you're capturing is being permanently destroyed through incineration or whatever the chemical compounds you're grabbing require for permanent destruction?
Yes.
Thank you.
Thank you, Kim. We have Mark, then Sam, then Andrea, and I want to invite any RAB members who haven't spoken. We'd love to hear what's on your mind, and I'd love to get you in. We have another 15 minutes or so in this kind of formal period. And I also want to remind RAB members that the produce presentation, feel free to ask questions about that. Now is a good time. So let's go to Mark and then Sam.
Yeah, I think this is also for Hank. Going back to one of the first GIS layers that you showed of the various layers of material under the surface, whether it be overburden or bedrock or a couple layers in between. The first question is, does the entire area, is it floored by bedrock, solid bedrock, the wood, so to speak? That's the first question. And then the second question is, you showed, at least in some areas, and I didn't get the picture and I don't have it up before me, marine silt and clay, which you said was relatively impervious to groundwater and surface water penetration from the overburden. So depending on how widespread that is, how does it get down to the fractured bedrock if it has to go through the clay?
Okay, it's so I'm gonna share my screen again. And,
thank you.
Good question.
Yep, and hopefully people can see it. There we go. Okay, so the first question is about, I'm just going to turn these contours off. The first question is about the bedrock, and is it solid all over? It's we haven't drilled everywhere. I mean, we have a lot of holes that have gone into bedrock, we've gone down deep into bedrock, and some are shallow into bedrock. And just from, I mean, not just the holes that we drilled, the holes that have been drilled since the IRP days, the Installation Restoration Program, when the sites be investigated for fuels and solvents back in the late 80s. So we have access to those borings as well. So our knowledge of the subsurface is, you know, is pretty good. But the fractured zone, the highly fractured zone, the broken blocks, is really generally, and I'm going to use the word generally, limited to the top, you know, 10 to 20 feet of bedrock. And that's just from, you know, a lot of it is isostatic rebound results, you know, from when the glacier was sitting on it and it receded, and then the ground started coming up again because all the weight of the glacier. When that happened, the rock was brittle and it broke in sheets. And so that's why you end up a lot of times have this kind of really highly fractured zone near the surface of most bedrock formations in New England. So that's our conceptual site model, and for the most part, it's proven to be fairly accurate. You know, can you drill a hole 20 feet into rock and not find any water? Yep. But in general, you find water, and it's in connection hydraulically, in connection with the overlying overburden. Yes, fractured rock. Well, it's all the deeper rock is fractured too, but the frequency of fracturing is much less.
Yeah, so skinnier fractures and fewer of them.
Fewer of them, right? And sometimes you have big ones, but there's generally fewer of them.
Okay.
So that's the first part of your question. The second part of your question is, I got a layer I'm going to show you somewhere if I can get my table of contents all squared away. Let me close this. It's too busy here. Here it is. There we go. That's the marine clay silt. So this is that.
The orange.
The orange and the yellow. All the yellow orange. This hasn't been updated with all the new stuff we found, but the orange there is what was mapped previously by the USGS, and the light orange, for lack of a better term, is what we mapped during the early stages of this investigation. So during the base-wide site investigation, and also during the Site 8 investigation, we found some additional clays and we mapped them out, or this is marine clay silt. And subsequently, during this most recent round of RI investigation, we found more. So this map will get amended, and there'll be more zones of marine clay silt. So what you're looking at then is, this is that kind of that middle layer. This is the layer that's between the upper sand and the lower sand. So any where my hand is here, any material on top of this is going to be upper sand, and any material below it is lower sand, and then you hit the bedrock. So you can see that there's a lot of kind of holes in the marine clay silt. So in this whole area here, this whole flight line area, and I'll put the contours on now when we talk about this. Now I got the contours on here. This whole area, starting with the Site 8, this is the recharge area for the whole base, but also you're having water going off in two different directions. So this whole area, the flight line, is also a recharge area. So there is some clay, because we did find some, but generally speaking, there's not a lot of clay in this area. So this is how it's in when you have a recharge area, water, besides it moving perpendicular to these lines, it's moving in 3 dimensions. So it's also moving downward or upward, depending on where it is in the whole flow field. In areas where it's in recharge, it tends to go downward, goes vertically downward, as well as whatever direction the contours are suggesting. So for Site 8, for instance, up here, it's going to go from here out to the bay, but it's also in cross section. I'm just going to draw this in cross section. It's going to go down, and it's going to come up. and discharge into the bay. So because it's a recharge area, it's going to have a tendency to go down. So the same thing is going to happen here along here. It's going to be heading down, and then it's going to start coming up at the bay. So that's how it gets into the rock.
Oh, okay, but so like a follow-up is, so I picture these orange areas as almost like impervious plates. So the water above it would not pass down below. It would run across the surface and follow the contours that way, and likewise the water under it. Is that correct?
It can be. In some areas, the texture of this, let's put it this way. In areas where it's thick enough to put a well screen, you wouldn't want to put a well screen in it because it's not gonna produce water. Is there water in it? Yes, there's water in it. It's a clay, so it has high porosity, but it's not really interconnected. So it's not moving. So in some areas it's denser, so you might have exactly what you suggest, that you have it's completely impermeable in that section, but then you get a section where it's soft and kind of gooey and maybe siltier. And so you might get a little bit of transfer between the two layers, but really not. So it acts as in areas where where you have a lot of clay or marine clay silt, it acts as almost a perched ground where the water on top is acts.
That's what I'm getting at.
It's a perched groundwater zone, right?
Okay, I got it. Thank you.
Perfect. Thank you. I want to make sure we have time for Sam and then Andrea.
Thanks, Anna. I did have a question about produce, but I also have a couple about sampling and hydrology, I guess, that would be a good follow-up to that. And so the first one is, it looked like that there were a limited number of sample sites done outside of the PDA boundary, and I was wondering if they're, and what we did see inside of there seemed pretty much a mixed bag, like a lot of heterogeneity. So I'm wondering if we did more sampling outside of the boundary, we might expect some surprises. So I'm wondering if there's any intent or possibility of doing sampling a bit further away to see if there's anything else interesting going
on. Well, Sam, we have sampled outside the boundary, and there's some additional wells that we've sampled that we haven't got data back yet. So the whole intent of the approach of this remedial investigation work plan was starting off where we left off from the expanded site investigation, and we kept moving outward or down gradient, and we stop when we get clean. So or when we get to a discharge area, which would be the bays or the river. So we are continuing to move out, and so the next phase of work from a groundwater perspective, and we haven't scoped that out yet. That's coming up in the next 6 weeks or so. Is to look at the distribution of contamination and see where we have clean zones, where there's still kind of dirty zones, and move out and fill those data gaps. So that's the intent, is to kind of keep moving out until we can get our arms around this, so we can draw a line around the whole thing, so we can start establishing GMZs.
Okay, makes sense. And I guess, yeah, related to that, is this study period going to be enough time to give us a good sense of the mobility, the transport rate of all these different compounds within the study area? Or, I mean, obviously they're going to migrate eventually within the groundwater. So whether it's decades or what, are we going to be able to know that?
Well, that's part of the RI is a fate and transport section, and we currently have a groundwater flow model that's been calibrated, and we've been using that all along, helping us pick points and where to ideally put wells and so on. But we're building a contaminant transport model along with that, and we're going to look at the fate and transport of these contaminants. But I'd also like to point out, I showed you some of the contour maps earlier. that this use of AFFF, of this perfluorinated foam AFFF, began in the mid 70s here. So that's 45 years ago, and this is as far as it's gotten. So it's not moving terribly fast.
Thank you.
Thank you.
And just remember, so the majority of the volume of film that was sprayed was 70, 74, somewhere in there, starting until base closure became imminent in the late 80s. Although there was up until very, very recently, some much smaller use by the Air Guard and their training. The vast majority of the volume of AFFF that was sprayed was in that 20-year span in the 70s and 80s. I also just wanted to throw out there, Sam, in case, since you are new, and in case this helps you better understand the breadth of what we've looked at, that's not really presented here, but the group is familiar with, is a very extensive private drinking water well inventory and monitoring program. So it's not shown on the maps. There is some personal privacy protections as part of that program, but we did. Air Force did starting back in 2014, started doing an inventory of the private wells and has been sampling continuously since then. So, and that extends more than a mile from the base in just about every direction.
Thanks, Peter. Sam, are you good? Yeah, great. Andrea, actually pause for 1 sec. Members of the public, if any sort of last call for anyone who wants to make public comment, and then we'll manage time accordingly. If you would email Linda, her email is in the chat. So email Linda in the next minute or two if you'd like to make public comment, please. Andrea, thanks.
Thank you. Yeah, I just have like 3 more questions. So one is on incineration. I know that we talked about this at our last meeting, and it got brought up again today. So we know in the NDAA that passed in December, there was a requirement for a temporary moratorium on the incineration of PFAS substances, increased transparency surrounding incineration practices, and a closure of a loophole that may have allowed the DoD to improperly dispose of PFAS-laden substances by blending it with other fuels. And so I'd really like to know what is the Air Force and the City of Portsmouth's plan in terms of what you're going to do with the PFAS that you're filtering out if there is a moratorium on it and you can't incinerate it. Because I do want to say that, incineration, there's a lot of concerns with that too, in terms of, what happens to the PFAS when you heat them up that high? Do they become more airborne and then just go to kind of recontaminate another community? So I think there's a lot of concerns around incineration. And so given that that's in the most recent NDAA, is there a plan, like if you can't incinerate the PFAS that you're, gathering at Pease, what are you going to do with it?
Yeah, I'll take that, Andrea. So right now, the plan is once the moratorium is in place, that it's going to have to go to a Class C hazardous waste landfill. And that's how it will be treated until the EPA comes out with the final rule on what is an acceptable form of destruction for PFAS specifically. So once the moratorium hits, there will be no destruction via incineration. It's only going to hazardous waste landfills that are permitted to accept such PFAS contaminated wastes. So complete encapsulation, I assume, is how they would dispose of that until you find out what the EPA is authorizes as far as destruction otherwise. But that's the plan.
And is a Class C landfill lined?
Yes, it's the pretty high protection hazardous waste landfill. Yes.
Okay.
And just to clarify a statement I made earlier, previously we had incinerated the waste, and now we're landfilling it. So.
Okay. My other question is around state. I have a question about state standards and then a question about produce. So going back to the state standards, Chris, you had mentioned, a recent document that came out from DoD in 2021. Another PFAS community colleague of mine shared an Air Force document from 2020 written by John Henderson, who I think folks on our RAB may recall, we actually met with him a couple times. He came out and met with us, but it said right in there that that the Air Force would comply with state standards. And so I'm just curious, like, I feel like it's a bit vague. Is the Air Force going to comply with state standards in New Hampshire with these private wells? Like, I don't, I'm just not, it's just not really clear. And I just didn't know if you could just give us like a straight yes or no. We're going to go ahead and intervene in those 5 private wells that we know are above New Hampshire's MCLs, but below the EPA health advisory.
Well, Andrea, right now I'm waiting for the Air Force implementation guidance to come out. There are some conditions in there. The legal can correct me if I'm wrong. So far, that's it. You know, around P's, we know that the LHAs from the EPA have been exceeded in the area underneath the current ongoing CERCLA event. So those can and should be considered. I'm waiting for the guidance to give you the definitive answer, but it's a step in the right direction, I guess, is the answer that you kind of want to hear. So it's yeah.
Well, this is Sharon again, and the people think the new policy means that that the Air Force is immediately going to start treating every well that exceeds a state standard. And that is not what the policy said. The policy said if there are wells that exceed the LHAs, and if there are other wells around there that are hydrogeologically connected to the wells exceeding the LHAs, and the Air Force or any other OSD department has a reason to believe that eventually those wells would exceed the LHAs, then we can address those wells too. And when we do address them, we're allowed, not required, but allowed to use state promulgated standards such as an MCL for the level we would clean up to. But it's not, you don't look to see, does a well exceed the state standard, and that triggers you providing the water. You still look to, is there a well exceeding the LHA? Are there other wells hydrogeologically connected to that well? And do we expect the wells that are hydrogeologically connected to eventually exceed the LHA?
Sharon, can
But as Chris said, we are waiting for implementation guidance for that policy.
Can you say what the LHA is again and the MCL for people who are not as used to the acronyms?
Lifetime Health Advisory is the LHA, and that's 70 parts per trillion. It's EPA's Lifetime Health Advisory for PFOA, and there's one for PFAS, or you can add them together. The MCL is a maximum contaminant level, which is a Safe Drinking Water Act level that states set for some contaminants. And I believe New Hampshire has 4.
Thank you.
I don't have my cheat sheet out, but I think New Hampshire has 4.
Yeah. So Sharon, I have a follow-up question to that because, so it's my understanding, and, you know, folks on the call, correct me if I'm wrong, but, you know, there are wells that were above the LHA that the Air Force did intervene on. And that was before New Hampshire set MCLs. So then when New Hampshire set the MCLs, the Air Force refused to comply. And so I don't know if that matters in terms of the timing, because you're saying if there's wells that are above the LHA and if they're hydrogeologically connected to other wells, like what do we do that, you know, the Air Force intervened on some wells before we had MCLs. So now we have the MCLs and they're not intervening, but now there's this new guidance and it's like, it doesn't sound clear to me if the Air Force is going to intervene or not. So like Chris's slide said, this is a big win for the community. So I kind of like walk away going, okay, awesome. The Air Force is going to intervene in those 5 homes. But I feel like we're still hearing, like, we're not sure that the Air Force is going to intervene in those 5 homes. So I'm trying to find the big win on the slide. I'm trying to understand that.
Well, I don't think the slide should have said a big win because we don't know yet what the facts are going to be at Pease or at other installations or former installations. Before this policy even came out, as you know, the Air Force position was if there was an exceedance of the LHAs, the Lifetime Health Advisories, the Air Force or other agencies within Department of Defense, if they were in control of that area, took action to provide alternate water. And those are the wells, as you've indicated, that for quite a while, we've been providing alternate water. And of course, there was the EPA administrative order that compelled stuff to happen with Haven. All the new policy is saying, it doesn't say you go straight to MCLs and by golly, that's what we're running with. It's that whole bit I talked about before. The new policy is only really controlling, can we address wells that are below the LHA or LHAs, the lifetime health advisories, and when can we do that? And there's a process, there's an analysis that has to be gone through for that.
Okay.
There's a difference use for what the LHAs are for than what MCLs tend to be for. LHAs are, there was a decision made that if a well exceeded the LHAs, we were going to consider that to present an imminent and substantial danger to the people drinking the water, and we were going to provide alternate water. MCLs are longer term, and MCLs, like we talked about earlier with the cleanup standards that are going to get used at the ROD, that is something you look at for what is the cleanup going to be long term. Not is there an imminent risk now, because an exceedance of an MCL doesn't present an imminent risk now. It's what does it need to be for the cleanup later on? What the new policy is telling us is if you have one well that exceeds the LHA, there's other wells that are connected to it hydrogeologically. And if eventually those wells would exceed the LHA, when you go looking for a standard to clean those wells up to, we are now allowed to use the MCL. But we don't go looking for
Okay.
wells that exceed the MCL and say we're going to clean those up.
Okay, so it sounds like the Air Force is not going to intervene. I mean, I don't know the levels in those other 5 wells. But yeah, with you explaining it that way, it just doesn't seem like the Air Force is going to then intervene on those homes, you know? And the other thing I think that you said that doesn't quite make sense to me is that, like, an MCL is, in my understanding, is more enforceable than an LHA, you know, like an advisory versus a standard. I always thought an MCL was more enforceable, but apparently it's not enforceable to DOD, which I don't quite understand that. But
well, let's go back to your first question, and which I've already lost. I'm sorry. Oh, on the 5 wells. I do not know of a decision that's been made there because, as Chris said, we're waiting for implementation guidance to help us take this policy and make sure we implement it correctly. So once they get that guidance, they'll be doing the analysis. And I don't know if anybody's already done a back of the envelope calculation for those 5 wells or not. The second thing is, keep in mind an MCL, maximum contaminant level, is a Safe Drinking Water Act standard that applies at the tap, which means that's the water coming out of the tap is supposed to meet that MCL. We're talking about water in the ground, or maybe that's coming out of a private drinking water well, which is not required to meet state MCLs. MCLs don't apply to private wells. So they're used in a different way. They are often used when we get to actually cleaning up a groundwater source, but they have a different function than lifetime health advisories. Does that help?
I appreciate the answers, but no, I'm still confused. And I think in the interest of time, I'll just move on and ask my other questions. I feel like this is something we need to revisit. I mean, I'd love to know from New Hampshire DES if the MCLs don't apply to the drinking, you know, to the private drinking water wells where they've had to intervene and provide alternative water because they don't feel that level is safe. But yeah, I'm still a bit confused, but why don't we go ahead and move on in the interest of time? This is something we're going to have to continue to revisit. So my question for Amy, I just wanted to go back and ask more about detection limits for the fruits and vegetables. So I found it really interesting that there were no PFAS detected, and I was just curious if you can tell us what the detection limits are. Were they in parts per billion or parts per trillion?
Sure. Yep. And that's a great question. So the very short answer on that is that they were appropriate and that they were the lowest that the lab could achieve. So I'll just give you a slightly longer answer on it. And that is the process that we go through to set those. So we start by establishing these risk-based criteria. So what would be a safe amount of consumption for vegetables? And then we do the 10% of that, right? So we set what is basically a negligible risk value. So it's basically the same process that you saw with like shellfish consumption and the other media that we've been looking at. So we went through that process with the produce, and we talked to the lab before we went out in the field, and we established that they could meet the detection limits that we needed. So basically they could detect PFAS at a limit that was equivalent to or below our screening levels. So we went through that process, and then when we got the data back from the lab, we checked it to see, you know, did they meet what they said they would meet. And it turned out that they weren't quite as low as we would have liked them to be. They didn't quite achieve it. So, you know, we went back to the lab and we said, you know, is there any reason, you know, why didn't you achieve quite the detection limit? Essentially what they achieved was equivalent to our screening levels, but we thought that they would be lower. So they're still appropriate and they're fine. We're absolutely sure that we didn't miss any risk drivers. You know, I don't think there's, you know, there's nothing hiding in there that would be a potential risk driver. But we did see if we could get any lower limits. And they found that, you know, with this solid media, this biota, there was a lot of interference, and they had some technical issues running the data. We just can't get lower limits with a solid media that is kind of matches up with what you're able to see in the liquid media. So when you think of groundwater, you can get detection limits in the single nanograms, whereas in the produce, the detection limits were 1 microgram per kilogram, so parts per billion. So they are, you know, they're a little higher than what we're seeing in the liquid media as far as the detection limits.
So I guess what that translates to is it possible there's PFAS in the vegetables and fruit, but the lab was not able to detect it?
There's never going to be a zero. So we can never say that there's nothing there, right? Like it never gets down to zero. There's always a possibility that there is something there that's below our detection limits. What we can say is that whatever that is, it's not a risk to human health.
Okay. Okay, well that's interesting to know. In terms of the pasture grass, you were able to detect some PFAS in the pasture grass, and I'm just curious why you think there may be a difference in pasture grass versus fruits and vegetables. Like, I don't know, I know nothing about plants. So is it in terms of how they grow or where they were growing, or do you have any thoughts as to why one group was non-detect, but the pasture grass did have some detectable levels?
Yeah, so I think I mentioned in the presentation that we've been doing a bit of research into the different uptake factors and the different literature that's up there as far as, so plants, they don't necessarily take PFAS and put it into their different types of tissues the same way, in the same efficiency, if that makes sense. So something that's a fruit, it's a different part of the plant, and the plant is going to potentially put PFAS more or less there than, say, a leaf. So when we look at the different transfer factors that are available for plants, it typically suggests that leaves are the most likely to take up PFAS. So that would be like a grass, it's a leaf, right? It's a green part of the plant. If you looked at, you know, leaves of trees, you would see a similar kind of correlation. So leaves, leafy green vegetables that we eat, again, like that's more likely to take up PFAS than, for example, a fruit. So a lot of what we sampled, there were fruiting parts of vegetables. So a pumpkin or a tomato, a cucumber, that's all like a fruiting part of a vegetable, which again is different than roots. So we only had, I think, 1 or 2 onions. You know, that was the only root vegetable that we sampled. But again, it's a different plant part. So when we looked into this, we tried to, you know, maximize the amount of leafy green vegetables and green things like the pasture grass that we were sampling, thinking that that was our sort of our most likely detection. So, you know, we didn't see it in any of the produce, but we did see it in those pasture grass. And, you know, the concentrations that we saw that were taken up into pasture grass, they were in that estimated range. So there's the lowest that the lab can see is below the reported detection limit. It's actually a lower value than that. And it's a level at which it's just not a very confident value. Like they can't say, okay, well, they know it's there, but is it 0.6 or 0.8? You know, they don't have a high level of confidence of what the actual value is, which is why it gets J flagged. So it's quote unquote an estimated value. And so the ones that the lab did detect, they were all estimated, they were low concentrations. But so it was just, as I said, it was just those two chemicals, PFBA, and then that another one was like PFBEA. And it was only in those two samples, which were, one was a dry soil and one was a hydric soil. I think Brian was asking about correlations earlier. I wasn't entirely following him, but part of the reason we haven't done correlations is because there were so few detections. And when we look at what was detected, we don't always have the co-located media. So in that dry sample, we didn't take a dry soil sample there. So there's no way to look at what was in the dry, and in the dry soil, you wouldn't have really had a groundwater sample either. So there's nothing to correlate with that detection of PFBA. We don't really know why that's there. And then in the hydric soil samples, we saw one chemical at a very low J flag value. And again, it wasn't in the soil sample that was associated with that. So the only thing, that makes sense, unless it was, it was in soil, but it was below the detection limit, I don't know. But, based on the uptake factors that we see, they tend to be higher either for leafy green, but also from groundwater. So you can look at uptake from soil only or from groundwater only, right?
I'm gonna jump in and ask Amy, can you wrap up? I want to get a couple more comments in a moment. Sorry.
I think that was the main end point I was going to say. It was just that the groundwater, tends to take up more, be more efficient so if a plant is taking up PFAS, it's likely to be more efficient from groundwater than from soil. So I guess one possibility is that it was a very wet summer, and even at the best of times when you're watering vegetables, it's intermittent. They're not 100% in that water. It's not like a hydroponic kind of environment where you're constantly exposed to the water, like we saw with that, the plant that was in the sediment that was in perennial water. So
got it. Thank you.
Let me just jump in real quick if I can. There's something else to remember.
Hang on, one sec. Sorry, Peter. I just want to say for the members of the public, we received one set of questions. We think they've mostly been answered, but I'll just name them probably in about 10 minutes. So other members of the public don't want to speak. So we're just going to let this conversation go a little longer and make sure that we get also to Kim and Mike Donahue. But go ahead, Peter, and then we'll go to Kim.
Yeah, just something to remember, and Amy, correct me if I'm wrong, but of all the backyard gardens that were identified, none of these are in none of them are being irrigated or in contact with high surface water or groundwater contamination. So we're not looking at gardens that are being grown up at Site 8 or what have you. So we got very, very low water concentrations to begin with, and it's not a huge surprise that we're not seeing it. It's a good thing.
True.
Yeah,
the soil concentrations the shallow groundwater concentrations that were associated with the pasture grass are higher than the irrigation water concentration. So that's a good point, Peter. Thanks.
Okay. And just to circle back around to we're not going to solve it tonight, but to the private wells, let's just remember that the DS did step in. Nobody's drinking contaminated water in those wells in question. There's I can't remember the numbers off the top of my head, but we've connected at least one to a municipal supply line. We've provided point of entry treatment systems. We've got one person still on bottled water, if I remember. Somebody else did their own treatment system. So in the short term, no one is drinking contaminated water. And I'm sure that as this process unfolds, hopefully expeditiously on the Air Force's side, that this investigation very clearly will establish that these wells that have impacts are hydrogeologically connected to the source areas on Pease, and it will be a no-brainer for the Air Force to step in. Let's let the process
Yeah, and this is Mike. And also too, again, as Hank had sort of really gave a good sort of conceptual model of both the porous medium, groundwater transport. And, these wells typically, residential wells are typically sort of screened in rock. So bait and transport, as we sort of use models and packages that support the flow model, is much different and much more complex with the bedrock well. So that's why there's a greater amount of uncertainty associated with a bedrock well versus something that you could maybe more confidently sort of predict as far as sort of concentration as it migrates away from the site, that which is above the 70. So I think that's another sort of important element to the sort of the consideration of these wells, is the fact that they're bedrock wells. So there's a greater sort of bar of uncertainty around those wells, and that's why again that you don't want to play with uncertainty. It's not in anybody's best interest to play with uncertainty relative to somebody's drinking water quality. So.
Absolutely.
So let's go to, I'm going to ask Kim to share her comment or question, and then Michael Donahue, before anybody responds, because there may not actually be much time to respond. So I just at least want you to get out your pieces and we'll see what we can do. So Kim, and then.
I'm turning my question into just a comment because of the time limitation, but I also am not very satisfied with the answers, the legal answers from Sharon. No disrespect to you, Sharon, but I would like to see our next meeting really get a deep dive into this. I think the pre-recorded information that the Air Force would present on this issue might be helpful, because I also think it needs to be revisited because it's just dissatisfactory at this point.
Thank you, Kim. Michael.
Amy, can you put your slide back up that showed how you originally identified the areas to look at for both the gardens and the farms?
I can. It will take me a second to find it. Hang on.
Yeah. The reason I'm asking that is that I think there are significant areas in Newington where there are gardens that have high water table surface water. People don't even need to water their garden. So in looking at the slide prior to the meeting, I was wondering why these particular areas got selected, and I know you explained it at the start of your presentation, but again, if you don't look at surface water contact with growing media or with growing areas, I don't think you're going to fully answer the questions that people have. And in fact, the data that you do have from the one area where there is constant water shows that there is more PFAS there. So if you can put it up, it seemed to be kind of limited. It wasn't, I know it was based, as I recall, you explained it, it was based on some earlier screening that you had done that from input you had received, but
Let's see, Amy, can we do like 2 minutes on this of like how you chose what you chose, and then Michael and other RAB members, maybe we can continue the conversation.
Sure.
Via email, looking at that slide or something.
And
Yeah,
Amy, I have the hydric soil map if that's helpful.
If you want to, yeah, for some reason Zoom isn't letting me share, even though I have the PowerPoint slides open. But so the shallow groundwater is definitely an interesting one, but so we didn't look at whether or not gardens are necessarily in a shallow groundwater area, because those areas wouldn't be conducive to gardening. They're kind of areas that flood out seasonally, so they're not typically places where one would actually put a garden. Typically, we did, when we sent this survey out, we did ask if people were using surface water to garden or had flooding issues, assuming that if they're in kind of a hydric soil area or poor drain soil, and they're having this, like their gardens are getting inundated regularly, then we would pick them up with this questionnaire. And we did send questionnaires to this entire area of Newington. So I would think that if there were people who were impacted, as you just pointed out, that they hopefully would have contacted us. But if there are people who are impacted in this way, I would encourage them to fill out questionnaire B, which is still on the BRAC website, because we would love to hear from them.
Without putting up that slide, it's delaying everybody. So this slide doesn't explain this at all.
Let's pick this up. Let's pick this up between RAB meetings. Thank you, Mike. Sorry, Amy. Just because it's late. So we'll carry that conversation on and figure out what's going on there. Thank you. So we had, whew, sorry, I feel like that was very abrupt. Thanks for letting me letting me do that. Thank you everyone for that really in-depth conversation. I think we picked up a bunch of different threads, and we got one member of the public who asked some questions that we believe were answered about sort of whether the DoD guide, how the guidance gets applied and when, and kind of who sets things. So in that back and forth.
Right. The only thing I have to add is that we hope the implementation guidance comes soon. I don't have a date, so
okay,
please be
great.
patient. Yep.
Thank you, Chris. I'm going to name some themes I heard tonight, just in case that's useful, and then go through some next steps that I know are on the books here. And then I'm going to give all the RAB members a chance to share final things on your mind as we wrap up. So some themes that I heard, and we were taking notes and we'll put out a summary, were everybody trying to really understand and get your minds around what was found in all of this data collection, where is the contamination, how is it moving, right? Through what, at what rate, volumes, things like that. Where and how is the contaminated, the sort of contaminants that are removed, where are they disposed of, and how is that kind of going? What do we need to know? People have mentioned several times concerns about places being protected now, right? Nobody wanting further contamination. And then finally, last and definitely not least, a desire to really have more conversation around how the standards will be chosen for the record of decision so that people can understand that, and if at all possible, help shape it or inform it and in whatever way they can. So that was a big request. Next steps, we are going to write a meeting summary. We will revise the action items spreadsheet, which some of you will have noted we're circulating again after meetings to just track those. We are actually, Cameron, when you have a second, can you put the evaluation link into the chat for everybody? We have a just 4 or 5 question evaluation. We'd love everybody to take like 2 minutes to let us know your thoughts on the meeting tonight, because the co-chairs really take into account what we hear back, and we're trying to shape this so it works. We are going to export this recording to get it posted so anyone can watch it, as we do with all our meetings, even our in-person meetings we record so that people who can't be here can stay caught up. We will update our contact list with our new members and get that out to RAB members so you can contact each other. We'll get the table from Hank showing the numerical levels of the PFAS out to the committee so that you all can look at that. And we'll follow up with Mike Donahue and Amy about the garden question. That's what I've got. There may be more when we go through the next through our notes, but that's a good starting place, I think. And let me see what I'm forgetting in our annotated agenda before I.
While you're looking that up, I just want to let everybody know that we are now looking for volunteers if anybody's doing any maple syrup tapping. So we're going to send out some questionnaires, and if anybody does any of their own tapping or knows somebody or a neighbor that does, we're going to send out an email where we have a new questionnaire. We're trying to identify people and properties that do this, if it's a common practice in the area, and whether or not it's worth sampling if they're in a contaminated area, and just to see what uptake is like for maple syrup in the area. So pay attention for an email. We're hoping to get that out sometime soon, probably just so the RAB members of RAB can spread it. The community can spread it out via that, via email or Facebook, whatever you guys do. That would be great. And then we can work on that, getting that done.
Perfect. Our next meeting is going to be April 12th. We're going to figure out kind of what format that is in. It's also going to be sharing more data. And I don't have shorthand list of what it is. Somebody remind me, sediment?
Soil, sediment, surface water, eggs. And yeah, we have to have a little internal debate. I think it's going to be a little less intense than this one. Groundwater is a vast topic for peas, and the other things it's a little easier to grasp. So
Great.
More data to
Shellfish.
come. And shellfish, yes. Fish and shellfish.
Great. And let's do closing thoughts. So RAB members, I will call on you and invite you to share anything on your mind as we wrap up tonight. Can be just a quick thanks, can be questions, responses, really. And I think I'm just going to go more or less alphabetically by last name. My list is not perfect, but let's go to the two Mikes. So Mike Daly and then Mike Donahue. Final thoughts.
I thought this was a good RAB meeting. I hope everybody thought it was good. It seems as though the recordation of the presentations were appreciated, so that's good. I don't know if you've, what's sort of amazing about this particular study is just the immense number of data points that are being collected. So this is building on already a pretty significant, massive database that existed that before Wood's involvement on the PFAS program. So, you know, probably one of the most studied areas in the state of New Hampshire. So that continues to grow. And you know, you can see by just, again, thank God for GIS to try to manage all this data. And again, it's data building on other data points. So there's a lot to sort of consider for me, and probably I can speak for DES to say that there's a lot of data to sort of sift through and to try to understand. So like yourselves, it doesn't happen overnight. It's not, you know, it's not through osmosis. It takes a fair amount of time to study and to sort of put it all together in our heads to try to figure out next steps. So I just wanted to give everybody that sort of perspective as, you know, as we continue to move forward. I mean, there's still more data to be collected, and it all has to be put into this larger, big story that we're trying to tell relative to nature extent and what it means as far as future steps being, you know, remedy. That's really where we're heading. So, so anyway, that's just my little bit of perspective. But thank you tonight for everybody's participation, the questions.
Thank you, Michael, and then Brian.
I just want to thank the Air Force for embracing the different way of presenting this and doing it in advance. And I think that if you compare this with what the session we had last August, it's a night and day improvement. So thank you. For the future, I really picking up on what Mike Daly just said. I think this data would be a lot more absorbable if you built on what you've done, but you presented it in three different lenses. One would be for the base proper, the base itself within the installation. The second one would be for the North Newington Peninsula. And the third one would be for South Newington and running into Greenland. Because when we look at these things, the information has been shown to us to be wonderful, really, that you have that you've gathered. But oftentimes the screen doesn't show in the detail the areas where people are actually living. And that is something that given that it's clearly off the installation at this point, we're in the off the installation era, it would be very helpful if there were more of a focus on being able to understand the data as it relates to where people are living.
Thank you. Brian and then Joan.
Well, I would only add, I would like piggyback on what Mike just said. I mean, some of the monitoring wells, we've got 8 years worth of data, so it'd be kind of interesting to see changes over time. I mean, it's still, ever since day one, to me, it's still, I don't fully comprehend that, you know, you can have a very high contaminated well and 100 feet away, you've got another one that's not, and then has that changed over, the years? Because, I said way back when, it's like, well, then let's just grab these really contaminated wells and get the contamination out there. So I think concentration is over time. I mean, we know it at all the drinking water wells because we have hundreds of data points over 8 years. So we know how the trends are going, but it'd be very interesting on some of these the monitoring wells to see trends over time.
Thank you. Joan and then Chris. Wait, I want to hold you, Chris, to the end. Joan and then Mark.
Okay, thanks, Anna. Yes, I like the new format better. And I also like Mike's suggestion of presenting it in sort of the progress of the 3 different areas. That's my comment.
Thank you. Mark and then Kim.
Yeah, I'll endorse the format. It gave me time to review and think about what was being presented and ask quasi-intelligent questions. And particularly with the next meeting, my hunt is aquatic ecology, shellfish, fish, water, sediment. I'd like to have a look at that data as much in advance as I can, so I can get my act together.
Thank you. Kim and then Peter.
Well, we talked about a lot, and the back and forth can be very technical at times, but the goal really isn't very technical. It's pretty simple. And I hope we're all on the same page about it, but this is the Restoration Advisory Board. It's not about providing clean water to households. I mean, in the interim it is, but the goal is the restoration of the aquifer, as I understood it when I first signed up. And I think that if we all have that same goal, we don't have to get lost in the details of how much the Air Force is willing to do and how much they are not willing to do. And we're an advisory board. So I do hope that people who are making decisions accept our advice on what's best for our community, not just for now, but for future generations. That's my comment.
Thank you. Peter and then Jean.
I appreciate everyone's input and concerns, and it's hard to build on anything else or offer anything that hasn't been said already, but if anyone that ever has questions, feel free to reach out. I'm always here, and welcome to the 3 new RAB members.
Thank you. I realize Jean looks like stepped away. Maria and then Bill.
Yeah, a couple comments came up tonight. Kim is right. We talked about a lot of things, but there were some questions about operations at Pease and at the airport. And I guess I want to just take the opportunity to reiterate that we're very aware of the environmental impact of the Haven well being out there. We do inspections, we do trainings. Development projects don't start until we've had pre-construction meetings with the contractors and the developers. We have meeting with our airport tenants and our employees. So it is at the forefront of our minds. And I just wanted to just repeat that. And that's it.
Thank you. Bill and then Russell.
Hi. So it was interesting for me coming on in my first meeting. There was an awful lot here, an awful lot to digest. But I guess the thing for me was being able to look at the historical, sort of mission statement and the purpose of the RAB and what had gone on previously. I was provided with a lot of reading material to get caught up to speed with. So certainly the format helped somebody new like myself to be able to come up to speed, and then to see how the meeting, took that sort of that goal of the RAB and then how it worked, where the rubber hit the road here was certainly helpful for me to understand and to play an active role in future meetings.
Great. Russell and then Sam.
thoroughly enjoyed listening to all the different arguments. Going to what Brian had mentioned a little while ago, I'm very interested to see on Site 8, for instance, the amount of water that has been removed and the amount of contaminants removed, to see if there's been a change in the concentrations over the 8 years. I mean, there should be real results there that we can actually measure and look at. Also interested in essentially how the whole law is being looked at, because of my understanding is this particular chemical group has not really been assigned true tox data. It's really kind of a supposition on cancer causing, what type of cancer is being caused and things of that nature. So I'm wondering how the Air Force, for instance, is going to be able to say, all right, these concentrations are like a lethal dose or something of that nature, where we don't have scientific studies that are backing it up. So that's kind of where I'm coming from right now. I thought all of the analysis was absolutely spectacular, what has been doing in terms of the wells and the different ground layers. Very fascinating. Appreciate it.
Thank you. Sam and then Matt.
Looks like we only got a minute, but yeah, I enjoyed the meeting a lot, learned a lot. I look forward to doing an on-site visit some of these places when time allows. And I also echo what Andrea said earlier. I'd love to get access to as much data as possible on all 25 compounds that were tested for, et cetera, because as Russell just said, this is an emerging area of science, and we're not even sure what the toxicity or effects of all these compounds are yet. And at some point it may be important. So yeah, look forward to the next one.
Thank you. Matt and then Andrea.
Yeah, hi, this is Matt. I think it was a good meeting. There was a lot brought up. I've participated in the last probably 2 years of meetings, and I think this was a good format. As a lot of people have mentioned, there's a lot of data out there, and everyone's looking for kind of more of a presentation of that data. And I think maybe more of a timeline of when the draft RI report might come out. Maybe if the RAB could see it as a pre-draft or what that timeline looks like might be helpful. So that's my comment, and have a good night.
Thanks, Matt.
Yep.
Andrea and
Yeah, thanks, Ona. Yep, I just want to also say welcome to the new members. I really appreciate you stepping up to serve on the RAB. We need everyone's perspective as we tackle this big issue. So thank you very much for that. Thank you to Air Force and Wood for the new format. I mean, it was, I think, much better. And the color-coded maps were great. Like, it really was very helpful. But the levels, Hank, that you did share with us were concerning. Some of them are really, really high. And I think our RAB needs some time to digest that and better understand what that means. And, you know, how is their treatment that's in place helping with those really high levels, and wanting to better understand that. And also, like, you know, we've never been able to get a straight answer, but predicting like how long the treatment's going to take. I don't think anyone knows that, but just seeing how high these levels are, it'd be helpful to know, have those dropped significantly? Are they moving at all? You know, like having a better understanding of that would be really helpful. And then lastly, I just want to say, you know, the discussions around the state guidelines, this has certainly been an important issue for the RAB for the last couple of years. We've sent letters, we talked about it at many meetings, and the fact that we still just don't have clear answers. And, you know, we have a slide saying a huge win, and then we have a legal person saying that's not true. Like, that's really frustrating. And I just think that our RAB deserves better. Like, I think we need more clear answers from DOD and the Air Force about what they're going to do to tackle those wells, that they are responsible for the contamination. They did contaminate them. They don't question that. I guess the question is, they don't want to follow New Hampshire state laws, which is unacceptable. So I hope that we can continue those discussions with clear answers, and that we're not being told two different things in the same meeting, because that really doesn't help with trust or transparency. So with that, I just want to say thank you for the meeting tonight. Thank you for all the information. I really look forward to the April meeting. I think splitting it up into 2 meetings is going to be helpful for people to try to digest all this information.
Thanks, Andrea. Chris.
All right, well, I'm glad to hear that people were excited about this format. I just want to say to those who were involved in this video, Amy, Hank in particular, the amount of work on that was pretty staggering. And the Wood team in general, there's a lot of people in behind the scenes that none of you all ever get to see, but thank you particularly to them for putting this together, and for Ona, for you for facilitating this whole thing. So this turned out to be a really good meeting. I know we talked about a lot. There's a lot in the works. Obviously, the next phase of the RI is ongoing, and it's going to start heating up as the weather warms and the teams get back out there. So we're a little bit more than halfway through it, and so there's going to be a lot more data to come, and we'll see how it goes. You know, fill in those data gaps and keep moving forward, heading into the report and then the next steps of this thing. So,
Great.
Yep.
Thank you.
Thank you, everybody.
RAB members, reminder, you can always approach Andrea and Chris, your co-chairs, with topics for discussion, things that you like, things you don't like. Also me, doors are open. We're trying to make this as constructive and productive a forum as possible. Hope to see you in person sometime this year. We're keeping our eyes on that also. And thank you all. Have a really nice night. We'll be in touch.
Right.